Amrita ma'am, are you in?
I'm just going to be.
Not able to hear your voice.
No, madam is not yet joined, madam. About to.
Amrita ma'am, are you in?
Madam,
Sir, good morning, sir.
good morning, madam. Amrita madam is joining now. Just a minute.
Oh,
Huh?
okay, sir. Okay, sir. Okay.
Good morning, sir. Sreejith, sir. Good morning.
Yeah, very good morning, sir. Am I audible there?
Yes, sir. Yes, sir.
Yeah, thank you, sir.
Thank you, sir. Welcome, sir.
Yeah, thank you, sir. Nice to meet you.
Yes, sir, you are audible.
Okay, sir. Thank you.
Sir, we'll start in another 1 minute.
Okay.
Okay, sir.
A warm good morning to all the participants. Welcome to the third day of the ATAL FTP Challenges and Control of Green and Sustainable Energy Systems using Artificial Intelligence Techniques. Today we have Dr. Sreejith as our distinguished speaker. Sir is here to enlighten us about the topic Introduction and Challenges of Wind Power Generation. Welcome, sir. I'm privileged to read Dr. Sreejith's profile. Dr. Sreejith is a graduate in Electrical and Electronics Engineering from Nurul Islam College of Engineering. He obtained his master's in Power Electronics and Drives from Mepkoshlank Engineering College, Shivakashi. He did his full-time doctorate at National Institute of Technology, Tiruchirappalli, on the area Power Electronics Application to Power System. Presently, he is working as Assistant Professor, Department of Electrical Engineering, National Institute of Technology, Silchar. Before joining NIT, he worked as Associate Professor, Energy and Power Electronics Department, School of Electrical Engineering, Vellore Institute of Technology, Vellore. He is having more than 16 years of teaching and research experience. He has published more than 50 papers in referred international journals like IEEE, Elsewhere, Springer, international conferences. He is a reviewer in IEEE, IET, Elsewhere, Taylor and Francis, Springer, and lot of other journals. He is serving as editorial board member in a few journals. He has given a number of lectures and hands-on training on power electronics, power systems, drives, FACS and HVDC, and smart grid. He is a member in board of studies in various institutions. He is guiding a number of BTech, MTech, and PhD scholars. His areas of interest are power electronics systems, renewable energy sources, drives, smart grid, optimization techniques, FACS, and HVDC, and electric vehicles. Thank you for joining us, sir. Please take over the session. Thank you.
Thank you, ma'am. Let me share the screen first.
Yes, yes, sir. Good morning, sir. Sir, could you please switch on your video for some time?
Yeah, 1 second. Let me do
Yes.
it.
Okay.
1 second. One second, I just stuck in this one. One second, let me change it.
Okay, sir, no problem, sir.
Okay, and start video. Is it? It's loading. Is it visible now, ma'am?
Not yet, sir. Yeah, now it's coming. Yes, sir.
And PPT visible,
Yeah, now
ma'am?
yes, sir. It's in PPT mode now.
Yeah. Okay. Very good morning to all. It's my pleasure to be a part of this SFPP. And let me thank the coordinators for inviting me as a speaker for this one. And thank you very much for the ma'am who introduced me. So the topic which we are going to see today is introduction and challenges of wind power generation. Okay, so actually, as per this topic, I'm not going deep into anything. I'll just give the introduction. What is a wind energy conversion system? Okay, why we need to go for this one, because this is a renewable energy. So let me tell you what is a renewable, why we need to go for renewable energy sources, and we'll see what is the scenario worldwide and in India. And after that, we'll move on to what is actually wind energy conversion system. Okay. Then we'll see various components in wind energy conversion systems. And finally, we'll see the challenges. What are the problems you are facing when you are integrating this renewable energy, especially wind to the grid. Okay. So I'm not going deep into the converter, machine center. Let's give you the basic ideas of all the components in the wind energy conversion system. Okay. So we'll start with the fossil fuel because this is actually a renewable energy source. So why we need to go for renewable energy? So that is a question. So that will tell you what is the fossil fuel, what are the issues we have with fossil fuel, all such things we'll see in a couple of slides. Okay. So these are things we are going to see today. We have only 1.5 hours left. So, and this is a very big topic. Okay. So I'll try to cover the basics as much as possible within this short span of time. So before going into wind energy, it's a renewable, as well as all know, it's a renewable energy sources. So first of all, we have something called as renewable energy source, right? So obviously something called non-renewable energy should be there, right? So we'll see what is a non-renewable energy source. As we already know, right? The name itself is clear, non-renewable. Okay. So if we take non-renewable energy sources, they are also natural. Most of them are natural sources, but they are non-renewable in nature. They cannot be regrown or they cannot be replenished once you consume it. Okay. And if you are seeing this one, okay, so mostly all the fossil fuels will come under non-renewable, right? And if you are seeing fossil fuel, mainly we have three things, right? One is the oil, another one is the gas, and third one is the coal. All three are there. We'll be using it for all our applications. We can't find any application without these fossil fuels nowadays. Even though we are telling that we are fully onto renewable energy sources, and there are a lot of countries they are fully into renewable, but still we can't avoid any applications without this fossil fuel as of now. If you are seeing coal, that's the fossil fuel. As far as our country is concerned, we can see that around 68% of the power generation is from coal only. Okay. If you see oil, yeah, we have petrol is there, diesel is there, all such things are there, and it's very tough to eliminate all these things, because if you see what vehicles running on the road, it's running on water or in air. Most of them are using oils. They are using fossil fuels and gas. For power generation, we are using gas. Even for cooking, also we are using all natural gases. So it's very tough to avoid fossil fuels. Okay, so it's actually there with our life itself. Okay, so the name fossil fuel came because they have been created by the fossilized remaining of plants and animals. And in this history, we have already studied, right? Millions of years before all these things got deposited, and the remainings of plants, they have been converted into coal, and the remainings of other living beings have been converted into oil and all, and we are using it now as fossil fuel. And if you see the fossil fuel, around 66% of the electric power in the world is from fossil fuel only. Okay, it's just electric power. Okay, sorry. And 95% of the world's total energy demand is from fossil fuel. So it's not only used for generating electric power, vehicles also running on that. We are using it for cooking. So a lot of other applications are there with fossil fuel. So if you see in general, 95% of the world's total energy is coming from fossil fuel. Okay, so at one side, we need to be happy that we have some resources which can satisfy 95% of our needs. Okay, we need to be happy that something is there which will satisfy our needs by 95%. Then why we need to go for renewable energy sources, or why we need to eliminate the usage of fossil fuel? That's a big question. Okay, because we have something which we are using for a long time, then why we want to go for the next one? Okay. The thing is that the first thing about fossil fuel is that they are not renewable energy sources. Okay, they are non-renewable. They are non-renewable energy sources. So once we are hello. I think now it's coming back to me. Okay, so they are not renewable energy sources. So once they start consuming it, okay, we are consuming at a very faster rate. Okay, so that we'll be taking coal today, it will get over, we'll go for the next location, there also it will get over, and once fine day it will come back to the same location where nothing will be left off, right? So they are not renewable energy sources, and we are using it in a very faster rate. See how much power plants are there, how many vehicles are running, all are using these fuels only. And these got deposited millions of years before that, 100 or 200 years before we have done all such things, millions of years before they got deposited, and now we are using it. Okay, so they are non-renewable energy sources. Okay, one fine day it will get over. So this is actually just tell you how the fossil fuels are. Okay, it's taken from Google, Wikipedia, and you can see the first one is coal. Okay, so we are using coal in a very fast rate, and as far as our country is concerned, nearly 68 to 69% of the power generation is from thermal power plant. Okay, and we can see we are utilizing in a fast rate, and as per this graph, you can see by 2081, assume that it's 2000, the entire coal ore in the world will get over. Okay, now we'll be running out of this fuel, so we need to find an alternate for this one. Okay, because they are not renewable. One fine day, everything will get over. Okay, see, it's not the only case with the coal, it's with oil and gas, everything is there. Okay, so one fine day everything will get over, so we need to find some alternate fuel which is renewable. Okay, so this is a not renewable fuel, so we need to go for some fuel which is renewable in nature, which should not end. Okay, it should be available today, tomorrow also it should be available, and it should be available throughout. Okay, so that's what we need. So the first thing about fossil fuel is their availability. They are not renewable energy sources, and soon their availability will be done. Okay, we need to go for an alternate fuel. Okay, let's begin with availability. Okay, now assuming that the fossil fuel is available abundantly. Okay, because the first case is that they are non-renewable and they are not available plenty. Now it's available, but soon it will get over. But assuming the condition that they are available, lots and lots of fossil fuels are available, still there is a problem with fossil fuel. There are problems with fossil fuels. Okay, the first thing is that that's bad for environment. Okay, see what are reasons I'm telling. These are not the only reason. They're not the only reasons. There are a few other reasons too, but just let me tell you the important things. Okay, so burning in fossil fuel is bad for the environment. Okay, and negative health effects will be there. I'll just tell you these things. Okay, the main drawback of fossil fuel is pollution. So that everyone will agree, right? Because whenever you're burning fossil fuel, you can understand how much is polluting the atmosphere. So if you go for a thermal power plant, just to see the picture of a thermal power plant at the top of a chimney, you can see how much it is, how much emission is there. Okay, so that's why when you go for power system problem formulations like economic dispatch, and we'll go for emission controlled emission constrained economic dispatch. A lot of things are there, right? So you can understand how much it is polluting the atmosphere. Okay, and this is not the only case with the power generation. This is also the case when you go for vehicles also. Right, what are vehicles we are running? They are running in IC engines, right? So when they are running in IC engine, either it is a petrol or diesel, they'll be polluting the atmosphere. Okay, so that's why we are trying to go for the next transformation, that is a electric vehicle which uses a electrical drive for the propulsion. Okay, so the first one is pollution. The next one is, when you go for pollution, there are a lot of other effects also. The very important thing is global warming. Okay, because as you are going for more fossil fuels, you are burning lots and lots of fossil fuels, the temperature of the earth is increasing, right? Then we will call it as a global warming. That's mostly because of the burning of fossil fuels. Okay, then climatic change. Okay, we can see nowadays we can't predict what is happening, right? Suddenly it may rain, suddenly it will be drought. All such things are there, right? So climatic change is there, pollution is there, global warming is there, and acid rain is there. That is one other effect of fossil fuel. But as far as our country is concerned, we don't have that much issue with this one. But there are countries where this acid rain is also prominent. That is, whatever gas is accumulated in the atmosphere, when it rains, it will come down along with the rainwater. Okay, so that we'll call it as acid rain. Okay, it'll harm all the creatures which are there in the earth, because we are not the only creatures in earth, right? There are a lot of other beings too. So these acid rain will affect all these living things. Okay, so availability is a problem, and if they're available also, they'll create pollution, they'll go for global warming, then acid rain, even health hazards are also there for human beings. Okay, so these are the issues we have, few issues we have with fossil fuel. So from the first thing we understood that we need to find an alternate fuel which is renewable, because fossil fuels are not renewable. But from these all points, you can understand that these renewable energy sources, I mean, the alternate fuel which are going to replace the fossil fuel should be free from pollution. There should not be any pollution from the alternate fuel which are going to use it. Then there should not be any, emission or global warming. Okay, there should not be any acid rain. There should not be any health hazard. So such things should not be there with the alternate fuel. Okay, so first one is the availability. We need to go for renewable. Then these renewable energy sources should not have any effect like this. Okay, so these are some of the issues which we have with fossil fuel. Okay, now let's see. If those things are called as non-renewable energy sources, then what are renewable energy sources? So from the name itself, it's clear, right? Renewable, they can be remade or they can be replenished. Okay. For example, sunlight and solar. If you're taking solar, sunlight is available today. Tomorrow also it will be available. Maybe some condition with partial shading cloud, that is all naturally available, naturally there, right? Apart from that, sunlight is available today. Tomorrow also it will be available. And day after tomorrow also it will be available, right? It doesn't mean that I'm consuming sunlight today and tomorrow it will get over. That is not the case, right? If sun is not there, that's all a life done, right? So they are renewable energy sources. They are there throughout, always. Okay. And if you consume today, it's not the case that it won't be there tomorrow. Okay. So it is always available. That's why they are called as renewable energy sources. Okay. And there are a lot of renewable energy sources. Okay, we have solar, we have geothermal, we have hydro, wind, biomass, all such things are there. Okay, but if we see the renewable energy sources, even all these things are used nowadays. But if you see this one, mostly solar and wind, they are dominating it. Okay, wind and solar. I'll just show the statistics also, what is happening worldwide and what is happening in India also. You can see wind and solar, mostly they are used as renewable energies. Even hydro is also there. Okay. So these are renewable energy sources. And you can understand, right? What are problems we had with the fossil fuel? It's not there with these fuels. One thing is that they are not renewable. This is renewable. Wind and solar. As far as sun is there, we can use solar. As long as sun is there, you can go for wind also, right? Wind power will be there as long as the temperature difference is there. Okay, so they are renewable energy sources. And what are the issues we have with renewable energy? With fossil fuel like pollution, emission, global warming, acid rain, you can't find anything with these fuels, right? Solar, there is no pollution, there is no emission, there is no global warming, nothing is available with this renewable energy sources. So you can understand that this is one of the best alternatives for the fossil fuels which we are using till now. Okay. Well, so out of these fossil fuels, out of these renewable energy sources, we have seen wind, solar, hydro, all such things are there. But after this, we are mostly concentrating on to solar and wind. Even hydro is there most of the places. Okay. So, but today's session that deals with wind energy. So let me start with wind energy now. Let me tell you what is wind energy, what is a wind energy conversion system, okay, and what are the components with the wind tower. Okay. So if you have been seeing wind energy, okay, so even if you see this one, there is a geothermal and wind, solar, everything is with respect to the sun only. Everything is with respect to the solar power only, okay? Because what we are saying at solar power, the radiation from the sun is utilized as either heat, as light or heat, like solar thermal. Even when you go for wind also, it's because of sun. Okay, because if I'm seeing the atmosphere, the sun will heat the atmosphere, but the thing is that it will be heated, not the same temperature everywhere. Okay, so the atmosphere is heated unevenly because of the lot of particles and other things available in the atmosphere. The heating will be uneven. Okay, so as it is heated unevenly, what will happen is that some parts will get heated more and some parts will get less heated. Okay, and as we know, when air it is heated, it will go up, right? The hot air will go up. So when the air is moving upwards, it will create a vacuum, and to fill the vacuum, cool air will flow inside. So that we will call it as wind. Okay, and the thing is that again, the sun is responsible for this one also. For solar and wind, both the same person is there. Okay, so that flow of wind we are utilizing for generating electric power. That we will call it as wind energy conversion system. Okay, so the sun heats the atmosphere unevenly. So some parts become warmer than other parts. Okay. Sorry. Okay, so as it's warm, okay, so this hot air will try to go upwards. Okay, so it will create a vacuum. So in order to fill the vacuum, the cool air will flow inside. So that we'll call it as, that we feel as wind, right? That is called as a wind. Okay, and we can use that wind energy. Okay, by using a wind turbine, we can harvest, and we can convert that into electric power. That's what we are using in wind energy conversion systems. Okay. Right. So if we see in general, wind is free, right? We don't want to have a fuel cost for this one, right? Because when you go for other energy sources, like if you go for coal, if you go for thermal power conversion system, that cost of fuel is there, right? If you go for nuclear, cost of fuel is there. If you go for diesel, also cost of fuel is there, right? Whereas when you go for renewable energy sources, solar, there is no cost of fuel, cost is nil. If you go for wind, the fuel cost is nil. And if you go for hydro, you will be having zero fuel cost, right? So this is free and no fuel is needed. Produce no waste or greenhouse gases. So comparatively, when you go for a thermal power conversion system, thermal stations, you can see a lot of greenhouse gases are emitted, right? Okay, and there will be a lot of waste. So you can see ash, I think, will be coming from our thermal power stations. Okay, so that waste is there. So this is not the only case with thermal. If you go for nuclear also, when you go for nuclear power plants, it will emit a lot of radiations. As you know, right? Nuclear plant will be emitting a lot of radiations, and nuclear waste will be there. So both thermal and thermal has the emission and waste. If you go for nuclear, it has a radiation and waste. Again, dumping this waste, nuclear waste is a very big issue, right? We need to go for a big trench inside the sea or in the near the seashore. Then we need to put all this nuclear waste inside, and it will take years for this radioactive property to go off. So that is a problem we have. So, but as far as the wind is concerned, there is no wastage and there is no greenhouse gas emission. Okay, and the land beneath can usually still be used for farming. This is another advantage we have with the wind energy conversion system. If comparatively to all the other sources, if I'm taking non-renewable energy sources like thermal, nuclear, they are power plants, right? So the entire area will be taken, entire will be utilized by the power plant. And if I'm going for solar also, the thing is that you'll be having solar power, you can go for either rooftop solar power. That is different. When you're keeping that solar panel in the land in some tilted position, mostly the place or the land below that solar plant is not utilized for any other works, right? We won't be utilizing it for any other works. Only the solar panel will be there. The land below that will be not utilized. Okay, because you see growing trees, growing plants below the land, that will create a lot of issues. Because if you're taking a solar panel, generally it is okay, but when you have trees, shading will come. When you have dust, okay, a lot of issues will be there in the power output when you go for shading, dusting, all such things. So most of the cases, the land below the solar farm is not used for any other purpose. But still, in some cases we are utilizing. For example, if you see the Narmada River solar plant, right? That floating solar plants are there. I mean, not floating. The solar panels are above the river, right? So they can take the sunlight and they can convert into electric power. Another one, they'll avoid the evaporation of water. Okay, and now we can see the floating solar plants also, which are there in water. But in general, if you are seeing, when you go for a normal application, the land beneath the solar panel is not utilized for any purpose. But when you go for this wind power plant, the land beneath the wind plant, okay, apart from the structure, tower and all, it can be used for any purpose. It can be used for farming. Okay, so that's one advantage. And a good method for of supplying energy to remote areas. So this is another advantage, because as far as our country is concerned, we can tell that it's 100% electrified, right? There are lots and lots of village places or remote areas where still they are there without power. Okay, so one problem we face is that our generation will be somewhere, and these areas are much remote. Okay, so carrying power till that end, constructing new transmission lines. I'll tell you the issues of that also while going for the challenges in wind power system. Construction these much huge transmission lines in hilly areas and all this very tough. Right, even the technology is improved now. Still, it's very tough to go for these transmission lines to these much remote areas which are there in hilly places and all. So generation will be on one side and they'll be on another side. Most of the places they are there without power. Nowadays also it's there. Okay, but this is one of the promising way by which we can supply power to the remote areas. Because we don't to go for, I think mostly this will come under the category of distributed generation also. That means we can generate the power near the distributed load side and we can transmit it. Likewise, in case of a remote area, okay, for example, I have a village which is near the hill, okay, somewhere inside that hill, somewhere it is there. This is applicable for wind, solar, and all, it's for everything. Okay, so there we can install a wind farm and we can generate the power and we can supply locally to that remote place. I don't want to install a solar wind power plant somewhere else near the city, go for 100, 200 kilometer transmission line and go to the hill. That is not needed in this case. But when you go for a thermal power station or when you go for hydro power station or when you go for nuclear power station, site is important. I need to put somewhere else and I need to transmit it. Okay. But as far as renewable energy sources are concerned, that is not the case. Okay. Only I need a certain mid velocity and some sunlight for if you go for solar. In case of remote places, I can build solar. This wind power plant there itself, take the power and give to the local area. So I don't want to go for 100 to 200 kilometer transmission because it's a small area. I can supply it. So this is one of the advantages we have. Even in remote areas, we can supply power without going for transmission lines. General transmission lines. Within that, we can just go for small lines and we can transmit power. So this is another advantage of wind. But this is there for solar also. It's common for them. Okay. So okay, now let's see what is actually happening in the world. Okay. What we are seeing till now is wind. Okay. But let's see why we are going. What is happening in the world, right? Okay. The thing is that what are details I've taken from IRENA website, okay, because they are the renewable energy website. They have a lot of statistics, data sheets, and all. Mostly the results which we'll take from them only. Okay. So what they are given is that the energy transformation by 2050. What is expected in 2050? Okay. So the first one we have seen is that, okay, we have lots and lots of carbon emission. Right. Even you can see, right, the countries will join together. They'll be conducting meetings how to reduce the carbon emission. Then they'll tell that this country is having this much carbon emission. You reduce it. Like a lot of things are going on. Right. Even India is having one of the best places in carbon emission too, in the top. Okay. So reduced carbon emission. That is one of the objective. Okay, that means energy transformation by 2050. What is expected in 2050 and what is the path for that? Okay, so by 2050, it is expected that the carbon emission will be reduced 70%, which is of now. Okay, what are available now, it will be reduced by 70%. So that is very important because carbon emission, that is the emission which we have, right? So our intention, that is by 2050, the entire carbon emission has to be reduced by 70%. That is the target. Okay, but the way to reduce this one is the usage or incorporation of more and more renewable energy sources, right? Because this emission is mostly coming from the usage of fossil fuels, right? So it's very tough to reduce that. It is very tough to reduce the emission from these fuels, right? Rather than going for all the control methods to reduce the emission, we can find an alternate renewable energy source. So one of the paths which is there for this one, reducing the carbon emission, is the usage of more and more renewable energy sources. Okay, that's the first one. The second one is falling energy cost. Okay, that means as we are going into the next year, that is from, if you see from 1990, 2020, all these years, we can see the cost of power generation from this renewable energy source is reducing. Right. Initially, when you go for 10 or 15 years before, if you want to generate 1 megawatt of solar power, it takes around 4 crore rupees to install a plant. Now it's came down drastically. If you see from 2010 to 2020, the cost of power generation reduced by around, from this website, you can see that it is reduced by 35%. Okay, so the cost of power generation is also less. So all these things, when you see all these things together, you can understand that if you want to achieve all such things, the better solution is using of more and more renewable energy sources. So first one is reduction in carbon emission. The next one is that the cost of renewable energy is falling down. Okay. Then job creation, that is the usual one, right? Because when you go for more and more renewable energy sources, more and more people will be getting job. And one more thing is that full energy access. That means 100% over in the world, they'll be having access to energy. If you see our country, that's what I told, right? There are a lot of people in remote places, they are there without getting proper access to electric power, okay? But when you go for more and more renewable energy sources like distributed generation, which is installed in the hillside or in the remote areas, then we can tell that by 2050, most of them have access to energy, okay? Then improved energy security. Improved energy in the sense that there are two things. One is that as far as our country is concerned, we are mostly dependent on fossil fuel, coal, right? But the coal which we are getting, the calorific value is very less, right? And one thing to increase because ash content is very much higher in the coal which we have. So washing the coal, that and all is not possible. So mostly we'll be taking coal from other countries. All such things are happening, okay? But when you go for more and more renewable energy sources, okay, so these dependency on fossil fuel will go, right? Because solar energy, when sunlight and wind, all those things are available, we can go for that, okay? We don't want to wait for someone to dig coal and send to us and generate power. That is what you can see in our country itself, right? So whenever there is a huge rain in some states from which the coal is coming, okay? If, for example, if you have a Ennore power station in Tamil Nadu, right? Coal is there from somewhere it is coming. Okay, so whenever there is rain in that state, the transport of coal will get affected and power generation here will be affected, right? So that dependency is there. But when you go for these kind of renewable energy sources, which is distributed towards the load side, these dependency on all such things will reduce. Okay, so I can generate locally and I can put it to the load. So that is one advantage. Another biggest advantage we have with this distributed generation, if you talk with respect to our country, okay, one of the biggest problem we face is that AT&C losses, aggregate technical and commercial losses in our country. If we see that Uday website is here, if you see the Uday website, you can see for each and every state what is the AT&C losses. There are some states with 8 to 10% losses. There are some states with above 30-35% losses. So think of a condition, 30 to 35% of the power generation is going as losses itself. Okay, and I'm not sure. Last week I was saying it's around the entire India we have around 21 or 22% it was there, but it varies with time. AT&C losses, aggregate technical and commercial losses. Okay, so that is very much higher in our country. But when you go for distributed generation, okay, see as you know, right, what is happening in the country, what is happening in power generation, right? We'll be generating power, we'll be stepping up to certain level, then we'll be going for transmission, then again we'll be stepping up to 400, 440. As of now we have 765 kilovolt, right? It will be transmitting in high voltage. All such things are there. There itself, a lot of losses will be there. When it comes to distribution system, okay, again we have a lot of losses because distribution system voltage is less, right? So obviously as voltage is less, the current will increase for power, so that I2R losses will increase. So if you see in general, aggregate technical losses will increase, right? Commercial losses, that is different. So everything, when you see everything, the AT&C losses are much higher in our country, it's about 20%. But when we see developed countries, it will be from 2 to 3%, like 6%, all such things are there, okay? But when you go for distributed generation like this, okay, as we are generating and supplying in the local, we don't want to go for huge transmission lines, right? That much distance of transmission line is not needed. So obviously the losses will come down. Okay, so that is the biggest advantage. We can reduce the losses. We can reduce the power. The power theft can be reduced because that I'll tell after this one. So improved security is there. Okay, and another thing is that as we know, right, we have the power system, right? If you are saying the power system, we have conventional grid, right? As far as India is concerned, we have 5 state grids, right? Regional grids, 5 regional grids are there, and 1 national grid. Combining all these things, we have a national grid also. So all such things are there, but this is an existing grid. Now what? Now we are going to shift from this existing to smart grid. Okay, when you go for smart grid, we can see lots and lots of controls are there, lots of advantages are there. So what are problems we had with all such fossil fuel, what we have seen, all such things, they can be easily eliminated when you go for such a kind of grid. Okay, so this is what expected in 2050, and one of the path for achieving all such thing is that using more and more renewable energy sources. That is what we are trying to put now. Okay, if you see, this is actually the projected graph. But up to 2020, that is a real graph. But after 2020, that is projected. Okay, you can see that by 2050, see 2050. Okay, see, because it's a energy transformation by 2050, right? So whatever is projected is till 2050, and you can see whatever graph it is there till 2020, that is a real time one. Okay, whatever is existing, it's there till 2020, and until 2050, that is projected. Okay, you can see by 2050, it is expected that 86% of the power generation will be from renewable energy source. 86% of power generation will be from renewable energy source. So you can see that by 2050, most of the fossil fuel based things will be eliminated and mostly will be depending on renewable energy sources. But it's very nice to see all such data and all, but how much impact is there on the grid? What upgradation is needed on the grid? That all they are the problems we have. But as a researcher, we need to find solution for all such things, because using a more renewable energy sources is advantage on one side, but integrating them to the grid, because existing grid, they won't accept these many things inside, right? So that is the next research work we have. Okay, and out of this 86%, you can see that around 1/3 is wind, and I think it's more than 1/3 is solar. Okay, you can see that these two are dominating fully. Okay, so out of this 86%, you can see 1/3 place is taken care by wind, and more than 1/3 is taken care by solar. Okay, so they are going to dominate. So this is what expected in 2050. Surely that will happen. If you're going in this speed, surely they can achieve this. Okay, and this is actually so this is actually the scenario with respect to the portion of all such things. Okay, the same graph which is projected in another way. Okay, this one is okay. This is with respect to our country. Okay, see, this is up to 2020 only. What we have till today is there. Okay, so if you see 2020, this is the installed capacity of renewable source in our country. Okay, you can see that it's around. See, you can see hydro. This is actually hydro. This blue color is hydro. Hydro is okay. They are maintaining that, but you can see this is wind. You can see the increase in wind installed capacity from 2010 to 2020. It's going on increasing, right? And you can see the increase in solar also. See, this wind includes both offshore and onshore. Okay, but mostly they are onshore plants, because we have less in sea. Okay, and you can see this. You can see how much the wind is dominating and how much the solar is dominating. Okay, so out of these three, you can see initially by 2020, you can see hydro and wind are there, but you can see now, I think they are equally placed. Okay, so 30, approximately 30, 30, 30. So if you go in this way, surely by 2050, most of the power generation will be from renewable energy sources. But see, we have seen only wind, but there are a lot of things also. Biogas is there. So if you take solar, there are two things, right? One is see, solar has two things, right? One is light, the other one is a heat. By taking the light, you can convert it into electric power by using solar cell. And when you go for solar thermal, you can utilize the heat in the solar, sun radiation, and we can use it for electric power or for other applications. So that includes both solar PV and solar thermal. It is a graphics not splitted. Okay, so from this you can see that they are dominating, and soon by 2050, most of the power generation will be from renewable energy sources. Okay, so all these are data are taken by IRE website, from IRE website. And this is a thing in general. You can see they are par now. Okay, solar and photovoltaic. Well, now let's go on to the wind. Okay, what is happening worldwide? Okay, so if you see by 2010, once again, okay, we see by 2000, only 1.7% of the power which is generated from renewable energy source was from wind. You can see, right? Hydro is there from very long back. Okay, solar is slowly increasing. But by 2000, if you see, nearly only 1.7% of the power generation was from wind. Out of that, 178 gigawatt is from this onshore, and very less from offshore. Okay, but when it went to 2000, you can see it got increased. Okay, and by 2050, you can see that 35. That is the graph. It's above 30 approximately. Okay, so you can tell that nearly 35% of the renewable power generation will be from wind power. And you can see that, see, just it's 2050. Okay, so from 2010 to 2050, within 40 years, you can see what is a change? It's from 178 to 5044. Okay, and from 3 to 1000, because initially the number of offshore is very less. Now they are also going to increase the offshore plants. Okay, and you can see from 1.7% which was there from 2010, by 2050 it is going to 35%. Okay, and you can see what is the power capacity. It was just 178 gigawatt installed capacity in 2010. Now it's going to 5044. This is worldwide, not for a country. Okay, and offshore plant also, initially it was very less because at that time the technology was not that much improved. Now we have lots and lots of good technology for offshore, especially that Hitachi ABB, we have HVDC light, right? All such things are coming into picture. Now they are going to increase the offshore also, because now actually when you go for onshore and offshore, nowadays people feel that things which are inside the sea, their advantages, because wind velocity will be higher, okay, less maintenance cost. All these are, and you can go for a higher power capacity turbine. All such things are there. So gradually they are increasing the offshore wind turbines. Okay, so this is the expectation by 2050, and surely that may happen. Okay, and this is actually the key milestone in case of the wind power industry. Okay, I'll just tell you by 1982. Okay, so the thing was you have a 3-bladed wind turbine with 22 kilo. I mean, the font is very small. This is the maximum you can project it. Okay, so by 1992, we had a single wind turbine with 22 kV, 22 kilowatt power. And as technology is improving, we can see that the 2001, we had a single turbine with 1 megawatt capacity. This is actually the roadmap. Initially, it was less. Now they went to 1 megawatt turbine, and we can see that by 2008, the capacity reached to 100 gigawatt. Installed capacity. See, power generation depends upon the time, the wind velocity, and they just tell about the installed capacity. But if you want to go get any information on real time, how much power is generated, see, this is the installed capacity, but the power generation will be different. When you go for thermal, if you go for nuclear and all, you can see the installed capacity. The power generation will be approximately near to that. That depends upon the load. Okay, but the thing is that when you go for renewable energy sources, the installed capacity will be different, but the power generation will be different. That depends upon the wind velocity, that depends upon the air density, that depends upon the sunlight. I mean, if you go for solar. So if you want to know the exact value of how much power is generated compared to the installed capacity, you can just log on into this website and you can get all the details. They'll give the data sheets, all such things. Okay, so this 2008, it was 100 gigawatt. Just after exactly a decade, after 10 years, we can see it's 5 times increased from 100 to 564 gigawatts. So just see what's the technology improvement we have now. So with the technology improvement we had from 2008 to 2018, 5 times it has increased. Now we have lots and lots of technologies. Okay, so we can expect that by 2050, whatever they are projected in this website, in this month, surely that will happen. Okay, and by 2019, the advancement is that we have 10 megawatt single turbine with 10 megawatt. Till that it was the highest capacity wind turbine, but now it is different. I'll show you another picture also. Now as of now we have a single turbine, I think in Netherlands, which is having a 14 megawatt capacity, single turbine. Okay, which is having 14 megawatt capacity. But in 2019, that was the thing. I mean, 10 megawatt was the highest one, but now it is 14 megawatt. Okay, from GE. Right, so this is the roadmap from the initial stage of a single turbine with 22 kilowatt model to a single turbine with 14 megawatt capacity. Okay, you can see how transformation is taking place and what we can expect in the next 20 years. See, 2050 is not so far, it's already 2020, just another 30 years or 29 years left. That's it. Okay, this one play. Okay, so if we see the components, okay, if we see the wind turbine, there are lots of components. Okay, so let me tell you the basic operation of all components. Okay, so if you are taking a wind turbine, okay, so we'll start from this one. Okay, so we have a nozzle. Okay, so as most of you have seen this wind turbine, right? You can see a tower and you can see 3 blades, right? That's what from outside, that's what you can see, right? You can have a huge tower, then we can see blades, 3 blades. But if you go nearer, then you can see the wind vane, anemometer, and all. But from distance, it's not visible. Okay, but let me tell you what are the basic components inside the wind turbine. Okay, we'll be starting with the. I'll just start from this side. We'll have a nozzle. So the entire setup is called as a nozzle. Okay, And first one is the rotor, that is we have the wind blades. Okay, so the wind will enter in the blades. Okay, so because of that wind, the blades will be rotating. Okay, so that's the first thing, wind will just strike on the blade. Okay, but if you see this one, these are all the general things which you can understand. If you see most of the turbines, okay, most of the wind turbines, you can see they have 3 blades, right? Yeah, sometimes very rare case you can see 5 blades also, but for small turbines they'll have 5 blades also. But most of the cases you can see they have 3 blades. Okay, there are a lot of reasons behind it. The first thing is that why it is not even, because all the turbines will have odd number of blades, right? Not even. Okay, odd number of blades. But then the question comes, why 3, why not 5? But if you see the turbine, they'll be having odd number. Never you will get a turbine with even number of blades. Because one reason, if you go deep into this one, you can understand that if you go for even number of blades, at any point of time, one blade will be in the top, another blade will be in the bottom, right? Because if it is 2 also, they'll be 180-degree apart. If it is 4, 90-degree apart, right? So always whenever you have a blade in the top, another blade will be in the bottom. That is shaded by the tower. Okay, so one will get more wind velocity, another one will be shaded by the tower, so they'll receive less wind velocity. That will create a lot of stability issues. So most of the cases they'll go for odd number of blades. But when it comes to the question that odd number of blades, why can't it be 5? Why you're going only for 3? That is the next question. Okay, the thing is that if you're going, you can go for 5 blades also, that is not a problem. But the thing is that if you're seeing the cost of a wind turbine, see each and every pass, once I explain, I'll tell you the cost. Okay, just in percentage. Okay. If you see the cost of a wind turbine, okay, so 2% of the cost will be for each blade. Okay, how much? It's 100%. 2% is taken by the blades. Okay, so first thing is that as you go for more number of blades, the cost will increase. That's one thing, right? Because 2% is taken by each blade. Okay, and each blade will take this much cost. So 3 blade means different cost, and another 5 blades means that is different cost. Okay, so that is one thing. Then the second one is that as you go for more number of blades, it's understood that the speed will decrease. Okay, so as we are decreasing the speed, if you want to match with the generated speed, then we need to add one more layer and one more thing in the, what is that? This gearbox. Okay, so one more mechanism has to be added, because as speed is changing, then gearbox has to be changed. Okay, so that will increase the cost, because if you see the gearbox mechanism, it will take around 15%. See, the blades and the entire rotor setup will take around 20% of the cost. If we see the tower, okay, I mean, along with all these accessories which are there in the tower, that will take around 15% of the cost. Okay, and inside that, the generator, the controller, all such will take around 34% of the cost. Okay, that's how it's generalized taken. Okay, so as we are going for more blades, the speed may reduce, and we need to add one more stage in the gearbox. That will increase the cost. So one side, more number of blades are increasing the cost, and gearbox also has to be changed. That will increase the cost. Okay, so more number of blades means obviously the cost is increasing. So optimally, they are going for 3 blades. Okay, so that is the first thing. So this air is entering into the blade, and this is rotating the turbine. It is rotating the blades. Then you'll be having a low speed shaft. So low speed shaft means actually it's whatever turbine is rotating, that is the shaft, right? So whatever speed the turbine is having, the same speed that shaft will have. So generally, if you take it, will be around 10 to 50 RPM, generalized, right? In the, so normally they will tell the wind speed in meter per second. We are converting it in RPM, like how much. In general, if you take it, will be from 10 to 50 RPM. Okay, so 50 RPM, assuming that it is 50 RPM, so it's a low speed shaft. Then after that, you'll be having a generator. Okay, so as we know, right, what the frequency we have is 50 hertz, a 4-pole machine. So the synchronous speed will be 1500. But you have this side, you have a low speed shaft with 50 RPM, but that side you have a shaft of a generator which has to be done in 1500 RPM. So you need to match these speeds. So we'll be having a gearbox which will have this matching, okay, which will convert the speed. Okay, so that's why you can see the size of that. One is a big one pin, another one is small one. Right. So in order to match the speeds of both of them, you'll be having the gearbox. So whatever speed the wind turbine is rotating, this gearbox will adjust according to that, and so that your generator will rotate in that speed which you mentioned. So that is the need for gearbox. But gearbox is a bit costly. So that nowadays, if you see the research, I haven't read it deeply, but you can see few papers with gearless turbines also. because that is a bit costly. Okay, so that is a function of gearbox. So it will adjust the speed according to that. Then you have a generator, then output will be given to the grid. Okay, but apart from this one, you can see a lot of other things inside this wind turbine. I can see one anemometer. Okay, second. You can see one anemometer, then you can see one wind vane. Okay, all such things are there. You can see one yard drive. Okay, all such things are there. I'll just tell you what is the need for all such things. Okay, so let me tell you, go for the next few slides, because there I have given in depth what is the need for all, what is an anemometer, why it is needed, what is the wind vane, why it is needed, what is the yard drive, why it is needed, all such things I'll just tell you in the next slide. 1 second, let me have a cup of water and I'll be back in 5 seconds. Yeah, okay. Right, so this is actually the construction. What are the components in Windows? So it will take a lot of sessions to explain the operation of each and every component, but let me tell you a few basic things too. Okay, so when the, okay, this is a power expression. See, these are the standard things which we have. Okay, so the amount of power, therefore, wind turbine can produce is given by this is actually the mechanical power, rho AVQ. Okay, so the thing is that rho is a air density. It depends upon the place and depends upon season. Okay, another one is A, that is our area of the wind turbine, how much it is covering. Okay, so from this you can understand, right? As area is increasing, as the length of the blade is increasing, you can get more power, but there is restriction also. Okay, so A is a swept area. Okay, and the thing is that as you increase, if area is increasing, okay, obviously you can understand that the power will increase. Okay, the power will increase. In general, if we see the practical things, okay, so the length of the blade will be maximum of 80% of the tower height. Okay, that means tower height is 100 means, okay, so it will be, if you see that diameter, that will be just maximum of 80%. Okay, you can't make the length of the blade same as the height of the tower. Okay, it won't be happen. Practically, that is not there. So now, if you see in general, the blade length will be nearly 80% of the height of the tower. Beyond that, you won't be using it. Okay, right. So that is the area. Then V cube. V cube is a wind velocity. Okay, so from this, you can understand, right? V cube. Okay, yeah, V cube. So the thing is that the power varies with wind velocity. As the velocity of wind is increasing, power is also increasing by 3 times. Okay, that means if the wind velocity is increasing by 2, I think 2 cube is 8, your power will increase by 8 times. Okay, so you see how much the deviation is there with respect to the change in wind velocity. Okay, then we can go for wind velocity like 100, 200 and all. There is also limitation is there, right? You have cutout speed for wind generator also. Wind turbine, you have cutout speed. Okay, so you can see that area is the one which is determining the power, but the area is fixed, right? Once you install the wind turbine, the area is fixed. Okay, the length of the wind turbine is fixed. The length of the blades, all such things are fixed. In between, you can increase or decrease the area, right? But the thing is that in generally, the length of the blade is around 80% of the height. Maximum, it doesn't mean that always will be 80%. Maximum of 80% of the height of the tower, the length of blade can be. Okay, it may sometimes it may be less, or sometimes it may be it will be less value. It won't be more than that. Okay, and velocity, the wind velocity depends on season. It depends upon the place and depends on seasons. Okay, so that is why this is intermittent in nature. Whatever renewable energy sources we go, it will be surely intermittent in nature. They are not fixed because this wind velocity will change with respect to season and with respect to time also wind velocity will change. Okay, but the small change in wind velocity, there's a huge deviation in power output. 1 meter, one change in one, then it will be cube. Okay, you can see it. If it is increasing by 2, it will be 8. Okay, so that is the thing which we have with wind power. Okay, and so this wind velocity, it doesn't mean that we can go for very high wind velocity. There is some speed called as cutout speed for wind, and that I'll explain you when you see the graphs. Okay. When you go for the types of wind turbine, we have two types in general. Okay, it's not with respect to the rotor or it's with the things and all. With respect to converter, we are not classifying. With respect to that turbine construction, we can have two types. One is horizontal axis wind turbine, because you can see the axis, right? It's horizontal. This you can see. So this is mostly used. Most of the applications now, hyper applications, will go for horizontal axis wind turbine. Everywhere also we are seeing it's horizontal. It's very rare to see vertical axis. Okay, if we see horizontal axis wind turbine, you can see that all these are this nozzle, all blades, everything, generator, gearbox, controller, everything is there in the top, inside that nozzle. Okay, so that is horizontal axis wind turbine. Okay, so whatever it is there, okay, everything is in the top. Okay, so the thing is that, so the advantage of this is yes, one thing is that as you can go for any height, right? Because as you increase the height, see, when you go for a ground level, you have trees, you have buildings, okay? So as wind is striking all these things, you can see a lot of turbulence and all such things will be there, okay? But when you are increasing above 60 meter, okay, we'll get a better wind speed. So as we increase the height of the tower, there is a chance that you'll get better output. Okay, so we can go for how much height you need. I'll just tell you the highest wind turbine. What is the height? I'll just tell you in the last slide. Okay, so we can go for height and all things are mounted in the top, so we can harvest more power. Okay, yeah, that is one thing. But the thing is that all these things are kept it in the top. Okay, so the cost is high. Everything has to be mounted in the top. Maintenance is also huge for this one. Okay, but when you go for vertical axis wind turbine, you can see this is how it is there. You can see all the things. Okay, a generator, all such things are there in the bottom. So it's very less cost. Okay, maintenance is very easy. Okay, but the thing is that we can go for height. I mean, we can increase the height to a certain level, right? So it will be rotating in the ground level only up to a certain height. Okay, so this is a vertical axis. But the advantage is that all the generator, all mechanisms are in ground only. It's very easy to maintain. It's very easy to construct. All these things are very easy. But nowadays, most of the applications will go for vertical axis wind. Sorry, horizontal axis wind turbines. Okay, now let's go on to the few controls, because we have seen anemometer, we have seen wind vane. So why these things are needed, or how we are controlling the speed of the wind turbine, that we'll see here. Okay, I'm not going very deep into all such things. I'll just tell you the basic. Okay, pitch control. The thing is that two things I'll tell you. One is that when you go for a wind turbine, okay, wind is striking the blades, right? So if the blades are straight, or if the blades are flat, okay, you can understand that the full entire wind will strike on the blade, right? It will huge pressure will be there on the blades, okay. Or if they are parallel to wind, if the blades are perpendicular to the wind, okay, then entire wind will strike on the blade, and the force which is exerted on the blade will be very high. Okay, they'll rotate, but the force which is there on the wind and there on the blade is very high. Okay. Another thing is that if you can keep the blades parallel to the wind, okay, so the entire wind will flow through that blade, right? It won't rotate. So normally we'll never keep the blades parallel, or we'll never keep it perpendicular. Okay, it won't be parallel or it won't be perpendicular. It will be just tilted or skewed by some angle. Okay, such that the force which is striking on that, the force which is on the blades will be less, but it will rotate. And by this one only we'll control the speed of the turbine. Okay, so pitch control means, okay, if the turbine will just skew such that it will strike on the blade and it will rotate. So it will be never parallel or it won't be perpendicular. That angle is called as a pitch angle. Okay. Okay. That angle is called as a pitch angle. So by which only we'll be controlling the speed of the wind turbine. Okay. And the thing is that, okay, so we need to control the speed of the wind turbine, but we need to understand what is the speed now, what is the wind speed now, because we need to control it, right? So we should not, there are two speeds. I'll show the graph. One is called as cut-in speed, other one is the cutout speed. Okay, below cut-in speed, we need to turn off, and above cutoff speed also we need to turn off the turbine. But how to understand what is the velocity of the wind, what is speed? That is where the anemometer is there. Anemometer will give you what is the velocity of the wind by sensing this. This is actually a closed loop control. By sensing this from the anemometer only, your pitch controller will work. Okay, according to that only the angle, pitch angle will be adjusted. Okay, so the blades are just adjusted such that it will rotate because of that wind. Okay, and if the wind speed is very high, the pitch angle is adjusted such that the wind turbine will stop, braking will be there. Okay, so that is actually the pitch control. Just skewing of blades. I'll just show one diagram will be there. Yeah, one small diagram will be there. It will be skewed by some angle. That angle is called as a pitch angle, by which the turbine will rotate. But nowadays you are having you are having electric drives, right? So that drive motor will be there, right? That drive will change the position of the blade. But this is called as a pitch control. And for pitch control, we need to sense what is the speed of the wind. Okay, so that is given by the anemometer. So if you go near the wind turbine, okay, you can see that the anemometer is there. But when you see far away from wind turbine, you can't see that. But if you go in the end of the nozzle, you can see the anemometer. Okay. Then the next one is yaw control. This is actually mostly employed in horizontal axis wind turbine, because when you go for vertical axis wind turbine, okay, so we have seen the picture of vertical axis wind turbine, right? If you see the wind direction, okay, for example, if I'm taking our country, for each season the wind direction will be different, right? Sometimes it will flow from one side, in another season it will flow from different side. So it depends on season, right? Each season, it depends on months also. In each month the direction of wind will be different. When you go for a vertical axis wind turbine, the axis is vertical. So whichever direction the wind is there, it will rotate, right? Because whichever direction the wind comes, vertical axis wind turbine will rotate. So no yaw control is needed for that. But when you go for a horizontal axis wind turbine, it is always facing one direction. The wind turbine and blades will face on one direction. Okay. So for one season, it's okay. But in another season or after 2 or 3 months, if the wind direction is different, it won't face that, right? You won't get the output from the wind turbine, or you won't get the exact output from the wind turbine. So that means that we need to make the wind turbine facing the direction, okay? Whichever direction the wind is blowing, accordingly, we need to make the blades or nozzle rotate, right? I'll just show you here when you're having this slide. I think it's right. You can see that the nozzle is rotating in this video, right? So likewise, depending upon the direction of the wind, okay, depending upon the direction of the wind, we need to change the nozzle. See, turbine tower is not rotated. It's not there, okay, practically. Only the top nozzle along the blade and all these things are rotated, okay. So it has to face the wind direction. So in order to face the wind direction, we need to rotate. So that control is called as yaw control, okay. Yeah, okay. Okay. So yaw control is used to change the direction of the nozzle. And you can see that we have a wind vane, right? So the use of wind vane is to identify what is the direction of wind. So anemometer will be measuring the velocity of wind, and wind vane, which is used to identify the direction of the wind, and according to that only this is changed such that it is always facing the wind direction, and you will get the maximum power output. Okay, so that is yaw control. Okay. Yeah, this is anemometer. Okay. And the thing is that when you go for so another 25 minutes left. Okay. So we'll go, if you go for wind, we have 3 speeds. Okay. One we'll call it as a cutting speed. Another in general will be calling it as a rated speed. After that, we'll call it as a cutout speed. Okay. You have seen that the output of the power is just, if you take all the remaining things are constant, proportional to the cube of the velocity. But we can go for 100 to 100 meter per second velocity. Stability issues are there. So there is some limit for the wind speed, right? So cutting speed is the one, that is the speed after which the generator starts giving power. The thing is that even if the speed is below cutting speed also, it will generate power, but it will be very less. That is equal to the losses in that. Okay, so mostly below cutting speed, that is the case. So obviously we'll never allow the generator to rotate if the speed is below cutting speed. Practically, if you see, it's from 0 to 5 meter per second, maybe it's around 5 meter per second, it will be. That depends on the turbines, 5 meter per second. Then we have rated speed. So cutting speed is the one, it's the speed at which the generator starts giving output. Okay, so below that we won't allow the turbine to rotate. Rated speed is the one at which you'll get the maximum power. Okay, then cutout speed is there. That is the maximum speed. That generally it will be from 20 to 25. See, these are vary with respect to place and turbine. 20 to 25 meter per second. So beyond this speed, we won't allow the turbine to rotate. If it is going beyond 25 meter per second, then surely if the speed is very high, then if you see the YouTube, you can see the turbine blades will get damaged. So below certain speed, we won't allow the turbine to rotate and generate power. After certain speed also, the turbine is not allowed to rotate because of the issues with the stability that will get damaged. So these two speeds are there. Okay, so cutout speed is the maximum speed beyond which the turbine is not allowed to rotate. We will be adjusting the pitch angle and we'll be putting brake and we'll be stopping it. Okay, because see, the one thing we have seen, right, when the blades are kept parallel to the wind will just pass without rotating the turbine. So just change the pitch angle such that the blades are parallel, so it won't rotate, and braking system is also there. Okay, so these are the three speeds: cutting, rated, and cutout. But how to sense all the speeds? I think for me it is closed by a window. I can see some anemometer on this side. Okay, you can see this. This is the anemometer. The function of anemometer is to sense the velocity. Okay. Because everything has a limitation, right? We have seen V cube, so you can go for 50 meter per second means it is expected that it will give much power, but that is not possible. 20 to 25 is the maximum limit. Okay. The cutting speed is the point at which the wind turbine is able to generate power. Below that also it will be able to generate power, but it is equal to the losses which we get in the turbine. Then there is no use of running it. Okay. Point it must be shut down to avoid damage there. See, during gusty wind speeds like storms and all, see the normal one we are telling it at 15 meter per second. But if you see storms, right, you can predict normally that climatic they'll tell today we'll have a storm, the speed will be 100 kilometer per second, 120 kilometer per second. See, think that if your turbine, if that storm is coming and if your turbine is rotating in 120 kilometer per second, you can just 120 kilometer per hour, it's not second. Okay? 120 kilometer per hour, then you think what problem will happen, right? So that's why you'll be stopping this turbine at some speed limit. Okay. Wind vane is the same. Wind vane is the one which is this. If you see different pictures, it will be different, but this is how the wind vane look like. It is used to identify the direction of the wind such that we can go for yaw control. So for pitch control, we'll use anemometer, and for yaw control, we'll use a wind vane. Okay. I'll quickly go through these things, okay, because we need to wind up 11. Okay, we have two more effects. I'll just tell what is wind wake effect. So wind wake effect is much prominent when you go for a wind turbine. Okay, say I have a wind turbine like this. Okay, I have a wind turbine like this. Okay, so when wind is entering this wind turbine, the blade will rotate. But after rotating the blades, right, the wind won't be the same as which is entering the blade, right? It will be scattered, right? It will be like a turbulence. A lot of turbulence will be there in the wind. Okay, I'll just show you on the picture. I think you can understand this. See, after entering the first turbine, it will be going like this. Then after second turbine, it will be going like this. So a lot of turbulence will be there in the wind. Okay, when it is passing the first turbine. Okay, so you have seen the wind farms, right? You can see some specific distance is there between the wind turbines, right? Okay, you can see some specific distance will be there between the wind turbines. They are not kept much nearer to each other. Okay, optimally, if you see, just see the length of the blade. What's the length of blade is then the next turbine. That is not the case. Okay. What will be the effective speed? Okay, just seen the question. Let me wind up this. So wind speed, the output you can see, right? As the speed is increasing, the output will increase. But the thing is that there is a limit for wind speed. So beyond that rated speed or cutout speed, we won't be allowing to generate the power. Okay. So as that from the relation we can see, right? As the velocity is increasing, the output. See, whatever it's given as a mechanical power. So as the velocity is increasing, surely the output power will increase. Okay. Okay, so when you go for this wind turbine, okay, so after one wind turbine is there, it is rotor is rotating, the air get scattered, and you can see a lot of turbulence will be there. So the power which is generated from this one, but the power which is generated from the next turbine will be lesser than this, because this velocity, all such things are different when it crosses the first wind turbine, right? So this is called as wind wake effect. The first turbine will have a certain power, and the second turbine power will be bit less. Okay, so generally that will happen. So in order to, this is called as wind wake effect. In order to avoid such kind of things, there are a lot of other technology. That means we'll give some specific distance between the wind turbines such that the second wind turbine is not affected by this one. And maybe if you see some other companies, right? In some companies, what they are telling is that the pitch angle of each wind turbine is slightly changed, such that it is not affecting the turbines. Okay, yeah. Okay, so this is actually wind wake effect. So the air gets scattered and a lot of turbulence will be there. First turbine will work fine. Okay, but after this one, all these things are happening to the next turbine. Okay, but there are a few technologies came by which we can avoid the wind wake effect. Okay, you can see this diagram shows this one. This is actually, so you can see first turbine is fine, but after that you can see how wind is going like this. Okay, so only this one will receive something different compared to the first one. Okay, so the output will be different, but there are a lot of techniques to avoid this. Okay, see this one I'll skip because of time. Okay, then one more thing, very important thing is a Betz limit. Okay, so Betz limit will tell you what is the maximum theoretical efficiency of a wind turbine. Okay, the maximum theoretical efficiency of a wind turbine is only 59.3%. Okay, that's the maximum efficiency of a wind turbine. That is, some calculation is there, you will get a 0.59, but it's 59.3%. That is called as a Betz limit. Okay, so that is the maximum efficiency, theoretical efficiency we can get it from a wind turbine. Okay, and practically, this is theoretically, practically it will be less than that. If you see practically, say it's 0.593. So sometimes it will be from 0.2. That depends on the wind speed and all. Sometimes it will be from 0.5. Sometimes it can be 0.5. So it can be from 0.2 to 0.5. Theoretically, it's 0.59. Practically, you won't get there exactly. So it's from 0.2 to 0.5. That depends upon the place and wind standard. So this is called as the Betz limit. Okay. Yeah. So common efficiency will be from 35 to 45 practically. Okay. And 100% efficiency. Another one is a power coefficient CP. In some expressions, you can see the power is multiplied by this CP. Okay, this is actually there. Okay, so this is actually the ratio of power produced by a wind turbine by the total wind power flowing into the blades. Okay, so this is called as a power coefficient C. Okay, these are the basic. Let me skip and directly I'll go to the challenges which we have because only 15 minutes. And this is a wind plant which is having the highest power rating as of now. But 3 are there, but I think 12, 13, 14 are there. 14 we'll call it as the highest power rating. Okay, so this is a halide X 14 megawatt. This is in Netherlands. Okay, you can see by GE. You can see the single turbine. Okay, by 2019 we have seen that the 10 megawatt is the highest power rating of a single turbine. Now we have 14 megawatt is the highest capacity of a single turbine. You just see what is the rotor diameter. It's 220 rotor diameter in the sense of, for example, if you have a tower like this, okay, if you have a tower like this, as in that this is an nozzle, okay, I have blade like this, as in that I have 3 blades like this. Sorry, it should be circular. Okay, so this diameter, okay, actually this should be like this, and this is called as the rotor diameter. You can see it is 220 meters. Okay, see how much it's very big, right? How much it is? Okay, so 210. This is actually in the land. This is not in the sea. It's in the land. 220 meter rotor diameter. So see how much this big it is. Okay, and tower height is 248. So it's understood that the length will be always less than that tower height. 80% of the length only. Maximum you can go for that length. I mean 80% of the tower height only you can go for the length. So you can see this much huge turbine which has a rating of 14 megawatt. But still this is up to 2020 or 21. But soon we can expect still more. Okay, right. Okay, let me tell you offshore also. See, offshore wind farm means the wind farms which are there in the offshore, not in the land. Okay, and but there are a lot of advantages. It's been told that offshore has good wind velocity. Okay, and there are no land acquisition. Okay, so there is no issue that when you go for wind power plants right in the land, it will affect the birds and a lot of such things are there. Okay, and people are not allowed to go near to that. But when you go to offshore, right, no such issues are there. Okay. Yeah, so that is people it's we understood that there are a lot of advantages with offshore. That is why when you see the initial one, some comparison we have seen, right? In 2010, we have only some 2 offshore wind turbines, but by 2050, it will increase to some thousands. So nowadays, it's understood that this is another advantages. So people are going for more and more offshore wind. Okay. And another one is technique. This with respect to one company, something called that is Hitachi ABB. Okay. Initially, when it was ABB, they developed something called as HV light technology, by which you can take easily the power from the offshore wind plant to the grid which you have. So this technology they have developed HVDC light. That is actually mostly with our voltage source converters with IGBT. Okay, they're using IGBT. They developed a technology by which you can take the power from the offshore power plant in the sea to the grid, which is there in the what is it, land. Okay, because what you are generating is AC there. Okay, then if you want to transmit AC, then you need to see that's a comparison with the AC and DC transmission. So they are converted into DC. Okay, they are converted into DC and they are transmitted to the land here also. So okay, same thing like HVDC, right? Some message. Okay. So the thing is that it's same thing like HPDC. Okay. So converting this AC into DC. So number of conductors with less reactive compensation is not at all such advantages will come into picture. And when it comes to land, it is again converted into AC and it is being used. So this is one of the promising technology when you go for this offshore plants. Okay. So for the next 10 minutes, 10:45, I'll just tell you what are the challenges we face with wind generation. Okay. The first one is compared to solar, wind is less predictable. Okay, so one thing I'll just tell you in general. Okay, the first thing is that they are intermittent power sources. These generators are intermittent power sources. Okay, intermittent energy sources. If I'm taking a thermal, okay, if I'm taking hydro, if you take thermal, if you're taking hydro, if you take nuclear, all such things, they are not intermittent in nature, right? For example, if I'm going to a thermal power plant, I know what is the capacity of that plant, okay, and depending upon the fuel input, okay, the output will change. Maybe the age, maintenance, all such things may change the output, but it is understood that if you're giving this, assume that there is no issue with it. There is no issue with the power plant. If you're giving this much input, okay, this much coal, if given as the input, you can understand that this much power will get it in the output. Okay, so that is understood. Okay, then the next one is that if you go for a nuclear, okay, or a diesel power plant, whatever it is, you can easily understand this will be the output which I'm getting if I give this much input. So input is under the control of the user, right? Input is under the control of the user. So they are easily predictable until if you have some fault, then it's okay. That is different. But apart from that, when it is working normally, okay, you can easily predict what is the output you can get it from the generator, and if you give this much input. Okay, so when you go for when you go for power system, you can see, right, economic dispatch, commitment of generators, there all such things are there inside power system. Okay, so when you go for a normal what is it, non-conventional like fossil fuel based sources, they can easily dispatch it because they know yesterday this was a load, this was a power generation, today this will be the predicted one. So according to that, they will give control to the generators to generate power. Then there will be slight variation in the load, and according to that, the generators will increase or decrease the power. That is generally happening. But when you are incorporating this wind into the grid, okay, wind in the grid, which is intermittent in nature, because see, wind velocity will change with respect to time, with respect to season, every day it will be changed. Okay, so when wind velocity is changing, what will happen is that output from this wind will change. Okay, output from this one will change. So suddenly what will happen is that it's very tough to dispatch when you go for renewable energy sources inside this. Okay, because all other generators we have, it is dispatchable. Right. This output is fixed from this generator. Will give this much output that is fixed, that we can understand. According to that, we can dispatch it. A small variation, that is okay, it will be taken care. But when you go for integrating these renewable energy sources into the grid, Okay, when you're going for renewable energy sources into the grid, we can't predict what is happening. A lot of forecasting methods are there, but practically there is a lot of difference between those things and what exactly happening, because all these things be happening because of nature, right? We can't predict what will be the wind speed. Suddenly it may change, suddenly it may decrease, suddenly it may increase. All such things will happen. They are intermittent in nature. And it's a case same for solar also, right? It's a case same for solar also. They are intermittent in nature. Okay, so as you have these many variations, okay, so the predicting their output, and when you're integrating this into the grid, so this dispatching is a bit tough as of now. Maybe after that you'll have a lot of new technologies coming into picture, things will improve. But this is one thing, okay, because this is less predictable. Okay, and the thing is that, but one of the advantage with the wind turbine compared to what is it, solar, is that the variation will be bit less. Because if I'm taking solar, you know, right, sun will be on one side, morning will be on one side, afternoon it will be on another side. It will be changing with respect to time. The radiation will change with respect to time. Then you'll go for MPPT controller to expect the maximum power at night time. Solar won't be available. So those things are there, but comparatively, the wind power output is not that much varying compared to the solar. That's as per the research. If you see, the output of the wind turbine is not that much variable when it comes to the solar. Okay, but still they are intermittent in nature. When you are connecting it to the grid, the dispatching is another issue we have, because when you're going for example, just to take a simple example of economic dispatch problem, will be what is the maximum length and minimum limit for a generator. Okay, so according to the load, we can tell that this is a generation. Okay, again, same wind also we can tell that this is the power it has to be generated by the wind turbine. But one fine day, if it is giving less than that, means where we'll go for the extra power. Again, we need to push all these thermal power stations to increase the power, right? And when you go for see, as in that you have two conditions. One is that suddenly the wind power is decreasing. Okay, suddenly the power output from the wind plant is decreasing. Obviously, they need to increase, because our ultimate aim is to meet the load. Okay, so when the power from the wind turbine power plant is decreasing, we need to increase the power generation from the other sources like thermal or whatever it is. But each and every generator has some limits, right? We have something called as ramp up and ramp down limits in generator. Right. So suddenly we can increase the power level to certain extent, and suddenly we can decrease the power level to certain extent. Okay. So that is very tough, right? And as you're going on changing the power output of all such generators with respect to the change in wind speed. Okay. So a lot of tear and wear, all such issues will be there. They won't be efficiently utilized. All such issues will come with the other generators. If all generators are working perfectly, for example, if wind is also fixed, means then no problem. Everything will be perfect. But this is varying with respect to time. So according to the output of these renewable energy sources, we need to adjust the output of the other non-conventional sources, which will create all issues with them. Lot of wear and tear will be there, efficiency will go down, all such issues are there. Then when you're going for ramping up, ramp down, all issues are there. Another one thing is that, okay, assuming that I have lots and lots of wind power now. I have lots of wind power now. So the extra saving this much capacity in battery is not possible now, right? So that means what generally people used to do, what generally has been done is that as you have more power from the wind, and one thing is that as far as we are concerned, we are moving more towards renewable energy sources, right? We are moving more towards renewable energy sources. So we are getting plenty of output from the wind. That means we need to utilize everything, right? It's very tough to store it. We need to utilize everything, right? So when you are utilizing all these wind plant power, obviously the power output of some generators has to be reduced, right? Because we are consuming all such things inside. So when we are reducing the power output, sometimes the generator will be, see, all generators will have the maximum and minimum limit. So generator will run to this minimum limit, okay. But in certain times, there will be some issue is that we need to turn off that generators because wind power is more. So turning off generators and turning on generators is not an easy task, because all these generators will have minimum turn on, startup and shutdown time. We can't directly shut down a generator. If it is running in some power, okay, directly we can't make it to zero, right? We need to have a ramp down constraint. For example, if the ramp down is given as 100 means, you can reduce it by, for it's running in 500. If the ramp down is given as 100 means 500, 400, 300, 200, like this only we can make it down to zero. Suddenly within 1 hour, we can put it to zero. Right. So if the wind speed is higher, obviously some generators has to slow down their output, or sometimes they'll be forced to shut down also, because we have a lot of inputs from the wind. But when it is shut down, when they are not operational, you need to see what is the startup time, what is the shutdown time, startup cost is there, startup cost is there, shutdown cost is there, then cold starts, hot start, all such things are there. So it's not easy to do all such things with the conventional generators we have with the thermal. Okay, so this variation in wind is affecting lots and lots of things when you go for other generations. Okay. Yeah, grid operators, because see, we'll be dispatching it. This is the output I want. Suddenly, wind power is reducing, where I have to run for power, right? Again, the only thing is that I need to go for the remaining plants, whatever we have to increase the power level. And sometimes you can see, right, the cost of, see, there are some power plants whose RAM rate is very less, but their cost of generation is higher. So we'll be utilizing that, means the cost of power generation will increase. Okay, so that is the problem we have with the grid. That's the problem we have with this non-renewable energy sources. Okay, sorry, renewable energy sources. Another one is that considering that we have plenty of renewable energy sources. See, for example, let me take the condition that just before 10 to 15 years, okay, I think that only the non-conventional energy sources were there. So when you're going to build a new thermal station, I think that I'm going to build a new thermal station, okay, the thing is that it will take approximately 5 years to build a station. Thermal station will take approximately 5 years, but it is understood that the thermal station will come in only in this place. Okay, and it's understood that where the loads are. Okay, so within these 5 years, there is enough time to design, plan, and implement an exact transmission system. Okay, see, when you go for research papers, right? When you read research papers, most of the papers will talk about the increasing in renewable power, increasing in wind, all such things are increased. But everything is done, all these things are done by keeping an assumption in mind that transmission is done and transmission is available. Okay, but practically, if we see that, if you want to go for a new thermal station, olden days it used to take 5 years. So these 5 years is there to take to design, plan, and implement a transmission system, because the generation location is known and the load centers are known. It's very easy to build within 5 years. They'll do it fine. Okay, and if it is getting completed within 36 months, it's one of the best things. But now, when you go for renewable energy sources, for example, a wind power plant is going to come. When it is a plant, right? When they're signing this one, it is understood that because these renewable energy sources takes very less time to implement, right? Very less time to construct and do all these things. So it will take approximately 18 months, assuming that the solar wind, okay, they are going to build a solar power plant, a wind power station. It will take 18 months. 1.5 years to come put it into service. But see, within these 1.5 years, again, the same design, planning, and implementation of the transmission system has to be done. Okay. Again, see, in the previous cases, in non-conventional energy sources, they had around 5 years time to do all these things. But now, when it comes to more and more renewable energy sources, the very less timing is there to build all these transmission lines. Okay, and building of transmission line is nowadays not very easy, right? We need to get permission from lots and lots of departments like forest, environment, aviation. In each place, if it is taking 1 year for getting permission, means within 18 months the project has to be completed, right? So going for new transmission lines within this short span is very tough. It's very tough. Okay, so that is one problem which is there with the expansion, because as lots and lots of renewable energy, then we need to expand the grid and we need to upgrade all the lines. But it's very tough to do all these things within a short span, because when you go for the implementation of a new power station, like renewable energy sources, it takes very less time. But in this less time, it's very tough to go for the upgradation of your transmission lines. Okay. And another one is that, okay, another thing is that, see, we have lots and lots of renewable sources, right? Plenty of renewable potential is there. Okay, so if you have more renewable potential and if your demand is very less, storing them is very tough. Right, but now we have an option. I just point out in US is there, UK, South Africa, and Indonesia also it was there. It seems they have an option to store the extra in megawatt. They have an option to store the extra power which is there from the renewable energy sources in the batteries. So whenever there is a huge demand, okay, whenever there is a huge demand or whenever the power output from the renewable energy sources is very less, the power will be fed from this battery to the grid, such that the grid is not affected. But as of now, we are in India, we don't have that. But so nowadays there is an option to store the power which is taken from the renewable energy sources also in batteries, and it can be used. Okay. And if I tell a few more challenges, because time is, I'll just tell you a few more challenges. The thing is that integrating this into the grid, right? It's with the existing grid, it's not very easy to put all those things inside. Okay, limitation is there with transmission. Okay, with the old infrastructure, we have issues. Then we need to go for synchronization. Okay, all such things are there with the grid. Okay, then power quality issues. See, I haven't talked about the power converters, but as of now, you can see now all renewable energy sources are using power converters. Without power converters, it's very tough, right? But as you go for increasing more and more number of power converters, power quality issues will be there, right? Because even if you make a single switching, then harmonics will be there. As you're going and increasing power converters, a lot of our harmonics will be there. Power quality issues will be there, but it's very tough to eliminate power converters and work nowadays, because whatever application we take, if you take solar, surely power converters will be there, minimum 2 converters will be there, right? And DC to DC, if you want, you can use it. And if you want to convert DC to AC to the grid, then you can go for grid tied inverter. In wind also, if you go deep into wind, they'll be using power converters like source side converter, grid side converter. So a lot of power converters are coming. As you go for more number of power converters, we need to think of the power quality issue. All systems. So intermittency is one issue, power quality is one issue, upgrading the existing network is another issue. Okay, so we are talking about smart grid and all, but when you go for all such things, these many issues are still there with our system. So only if you can eliminate all such things, then you can go for the upgradation for, I mean, you can go increasing the renewable energy system. So we have seen the initially by 87%, 86% of power generation will be from renewable energy sources. All these things are fine. But when you go for 86% of renewable energy source into the grid, how your grid is responding, how your transmission systems are upgraded, that is a big question. Okay, so that's why a lot of research is going on in this area. Okay, but mostly I'm not dealing with machines and all, because my work is with respect to some power converters for this one. That's why I'm just having dealt with machines, and it's a short time, so I need to wind up now. So that's all from my side. If you have any two things, I'll just, a lot of things are there to tell, but time is not there. So if you have any queries, you can ask now, or else if you have any queries or if you want any help in this one, you can put a message in my WhatsApp. Surely I'll help you out. Okay, so it's just an introductory section. So I just brushed about the basic concept of a wind power plant. Now it's up to the. I think in basically I got one question I have replied. If you have any questions, feel free to put it in the chat, or you can unmute and you can ask. I'll help you out. So it's to the coordinator now.
Good morning, sir.
So 1 second, let me increase the volume. Yeah, please.
Yeah, good morning, sir.
Yeah, very good morning, ma'am.
Yeah, like your session was highly fantastic and very highly informative, sir, about wind generation technologies. It's not a question, it's a part of the discussion. I want to actually know about these intermittent changes of these renewable energy technologies will able to make our target reachable by 2030, sir, because we are supposed to achieve an renewable energy target to the level of 450 gigawatt hour, and the lion's share out of it will be from the solar. But do you think that any research is vibrantly in the process, especially for a country, developing country like India, like digitally printed cyanobacteria or microflora embedded solar power panels? Do you think that any such kind of research is very much in the process in a developing country like India, wherein you need not worry about the intermittent kind of generation of electricity from solar or wind? Do you reflect your thoughts on this, even though you doesn't that topic doesn't actually belong, but I'm taking up from the challenges side, and I would like to know if you can just make an initiation in the discussion regarding this particular cyanobacteria and nanomaterials of solar cells.
Yeah, ma'am, it's a very good question. But the thing is that I'm just to tell with electrical point of view in which we are working. Okay, the thing is that it is understood that it's valid that they are intermittent in nature, they are not predictable. Putting them into service with along with the existing system will create a lot of issues. That is creating a lot of issues now. The thing is that now research is going on. Okay, one thing is that that's what I told, right? In India, it's not there, but I just told about 4 countries, right? And US, UK, then the remaining Indonesia and all, they have options now. That is the intermittency means it is less or more. Sometimes it will be less, sometimes it will be more. So whenever you have more power output, this is one solution which is being implemented. If you have more power output from the renewable sources, the option is to store them in the battery and you can supply to the grid when it is the output is decreasing. That is one option which is given and it is implemented. Another one is that we are just even that is in researchers because scholars will be working that only depending only on solar or wind is not working. We'll be having combination of all such things, all such renewable energy sources along with this battery storage, such that even though we have an intermittency or if we have issues with the remaining generation also, with the battery storage and with the remaining energy sources, we'll be adjusting this one. One more very important thing, which because that is not related to this topic, okay, but that is also that's a very important thing which we have. The thing is that as we are moving on to the era of electric vehicles, okay, so when you go for electric vehicles, it is understood that that's the one which is consuming power from the grid. But we have a lot of other technologies such as vehicle to grid technology, vehicle to building, all such technologies are there. So when you go for that also, one technology called as vehicle to grid is there because the capacity of the battery which is stored in the vehicle is huge, right? So when there is a power demand or when there is an issue with the renewable energy sources, so when the grid is not able to supply power to the load, the power from the vehicle is also fed to the grid in such that the problems can be eliminated. So the intermittency can be avoided. As of now, research is going in such a way that the intermittency can be avoided by using a battery storage system, by injecting power to the grid from the vehicles. Those two are seen as much as papers I have seen. These things are already there. Research is going on in these areas.
But don't you think that this battery storage technology will again pose an environmental hazard, sir?
Sure, that is there, ma'am. Because as we go for say as of now, what you're doing seeing is that most of them are using lithium-ion batteries, right? Because the energy density is very high in lithium-ion battery. In other side, lithium-ion is hazardous. So the wastage, I mean, you want to put it out. I mean, once age is once the lifetime is over, how to put it out? Okay, and this is a hazardous one. There is a non-renewable source also. So all such issues are there. So when you go to battery storage, next issue is coming. That is there. Even the same issues there with the electric vehicle also. That is why in the next, I mean, what is that? Research is going on with the remaining type of batteries like sodium and all such things. Just still more power density, but less. I mean, more life and more power density. So as of now, this is to considered to be a solution. But after some time, still more things may come. Obviously, the hazardous and wastage is there, but as of now, it's a temporary solution given. But still, the technology, whatever we have today is different. Whatever we have tomorrow will be totally different. So as we have more and more improvement in technology, surely we need to understand that all these things will be eliminated.
Thank you very much, sir.
Thank you, madam. Any other questions? I got some. That is the noise or another question.
Hello, sir. There is a question in the chat box.
Yeah, one second. Let me
Dr. K. Sreechandan has asked that, sir, can you suggest a better pitch angle controller?
Yeah, I can see the question. The one thing I can just tell you is that say when you're going for the work, okay, when you're, because there are a lot of areas of work in this, what is that, in this wind, okay, but there are some people may work with the wind turbine with this mechanical thing, some people may work in the controller, most of the few people may work in the power converters. Like this, the area is separated, okay. So as far as our work is concerned, we are mostly working with the power converters for integrating into the grid with all the renewable energy sources. So it's an assume that what we are assuming is that I have a wind turbine which will give this much power. After this, how to implement the converter to the grid? That's what we are working with. So there are a lot of areas to work with, and what he asks is that the pitch angle controller. So till now, it's whatever work is that we are expecting that we'll get output and we are working. But so that's why we have never gone to that type of controller where the mechanical things are involved. But surely I'll take up this question. It's asked by 1 second. I'm not able to find the name here. Just kindly put a message in my WhatsApp. Surely I'll find out the answer, because my work is mostly oriented towards the power converters which is inside. So, but surely I'll take up the question and put me a message in my WhatsApp. I'll get the exact answer for you and reply within 2 days. Okay. I think a lot of questions are there in the chat now. Okay.
So shall I read it out, sir?
I can see, Mama. I can read it out. Okay.
Okay, sir.
Let me come out from the bottom. Power quality, improve my filters, my instantaneous power, my enterprise. Surely that is what actually it's not with respect to the instantaneous power theory. We are still working on the power quality improvement by using, because already when you are going for power converters, the problem is that the harmonics. Again, power converters are used to reduce that also. So that is there. Surely you can approach me, okay? Because I'm not using this instantaneous power theory. We are using all different controllers for improving the power quality. Surely once you get time, just you can put a message to me. I'll help you out for continuing this work. Okay. And then the same question is about it. Can you suggest a method to identify optimal location of wind turbines with an objective to tap more power from wind energy? Okay, so actually, see, when a technology is improving, initially we had optimal location of capacitors. Then when fax devices came into picture, we had optimal location of fax devices. Now, as per sir has asked, I think I can see whether the name is below the text or above the text, but this question, optimal location of wind turbine. But one thing is that, see, when you go for an optimal location of other like fax devices and all, okay, so we'll just see only the power. When you're keeping a fax device in this location, how the power flow is improved, how the voltage is improved, only those things matter. But when you go for a wind turbine, so the location is very important, because we need to have that much wind velocity, air density, all such things are important apart from all other things. Okay, so these things, when you want to tap more power from wind energy, the location is very important. We need to find a location where you will get ample wind speed. Okay, so that is the thing which you need to consider. We want to find, because when you go for an optimal location of capacitor or a fax device, that is totally different. That is kept inside the existing system. So there, the natural facts like wind speed, nothing is taken into consideration. There, I need a location where if you put these capacitors, I'll get the power flow improved, or voltage stability, all such things are there. But when you go for this one, see, because the input is not under our control, so we need to find a place. See, for example, if you take India, in Tamil Nadu, we have two locations. One is Mupandal, other one is Pollachi something. Okay, in other state, Gujarat, we have Rajasthan, we have. So likewise, we need to find a location where we have ample wind velocity, because the minimum cutting speed is needed to take a wind turbine into service, right? So we need to find a location where we have ample velocity to locate, I mean, to keep it in that position in a test system. So say, for example, if I'm taking an IEEE 30 bus, right, leave all 5 out of 30 buses, when you go for any device, I can keep it in any buses. Okay, but the thing is that when you go for a wind plant, that is not the case. We need to keep it in a location where I have ample wind speed. Okay.
So one more question is there before that.
How the output, same question,
Yes,
huh?
yes, sir.
How the output power is constant after the cutting speed. Actually, for this we have two graphs. Okay, since I'm not working on that, I just haven't taken the graph. We have two graphs. there is a maximum output we can get it. See, there is a maximum speed we have it. Okay, so there is a maximum output we can get it from a wind turbine. Just one thing, I'll just you can put this question to me. I'll just share you the graph which tells you that is the maximum output we can get. But from the equation, it is understood that as speed is increasing, as wind velocity is increasing, the power will be cube of that, right? But that is up to only the rated speed. Beyond that, whatever power output is there, that will be maintained by the turbine. That is the maximum output we can get it from a wind turbine. Okay. Yeah, one more question is there. Intermittence effect is reduced by microgrids. See, if the thing is that when you go for microgrid, it is actually the micro version of the actual grid with more and more renewable energy sources into picture. But one thing is that when you go for microgrid, right, what our expectancy is that we'll be reducing the dependency on the actual grid, and we'll be having more and more renewable energy sources into the microgrid. But when you go for a grid connected system, obviously I have a grid already, so it is supported by the renewable energy. So that is the thing. Whereas when you go for concept like microgrid, where if you are mostly dependent on renewable energy, means obviously the intermittent effect will be posing lots and lot of things. But the thing is that when you go for microgrid, the size is very less, right? The size is very less. So actually it is very simple to operate this one. We can reduce the intermittence effect by having proper dispatching, by having proper energy storage, because in we go for microgrids, the capacity is less, right? So we can go for a lot of storage devices. So these things can be eliminated when you go for microgrid, not to the maximum level, but to a certain level we can reduce. Because see, when you go for a big grid, the battery storage and supplying power is very tough. Whereas when you go for microgrid, the capacity is limited. So we can obviously go for a lot of battery storage system so that these intermittent effects can be eliminated. Any other question? Actually, I need to rush up for a meeting by 11:15. Any other questions? Or if you have any still questions further, please feel free to put a message to me in my WhatsApp. I'll help you out.
So one more is the power quality improvement by filters by instantaneous power theory is my MTech project. How can I continue?
Yeah, the thing is that it is repeated. It is repeated. So once I answered for that.
So,
Yeah, the thing is, I'm telling, we are working on power quality improvement, but I'm not working on this instantaneous power theory. We are working on a different controller. So still, if you need any help on this project, you can approach me. I'll help you out. Okay, sure.
shall we wind up the session, sir, if you are in a hurry? Any other question from participants? I think there is nothing, sir. So thank you very much, sir, for joining us and giving us a session. Actually, knowing the challenges will definitely help us to find the opportunities, and so this will lead to new research areas. So I'm very sure that all the participants have benefited, immensely benefited. It was an excellent session, sir. Thank you very much for coming and joining with us. Thank you, sir.
Thank you, ma'am. It's my pleasure sitting at the extreme of Northeast and joining this one. It's my pleasure to meet you all. Thank you very much. See, you can approach for any help in this area. Thank you all. Stay safe. Thank you, ma'am.
Thank you, sir. Dear participants, now we have 15 minutes time before we start the next session. So at 11:30, we'll start the next session by Dr. Nagana Gouda. So we can take a break of 15 minutes now. Thank you. Good morning, sir. Dr. Nagana, sir. Hello, sir. Are you able to hear us, sir? So we are not able to hear you. We are able to see your screen, sir. It's clear. So can we start now? Nagana, sir. Hello, sir. Good morning, sir. Sir, can we start now? Nagana, sir. Oh. Hello, sir. Dr. Nagana Gouda, sir. Sir, are you able to hear us? Sir, are you able to hear me?
Sorry for the inconvenience, sir. Sir is having some issue with audio. So within a minute,
Hello,
sir
sir.
will get connected. Ma'am, sir will connect within a minute, ma'am.
Hello, sir.
Ma'am, am I audible?
Yes, you are audible, sir.
Hello, sir.
Ma'am, am I audible? This is Rupesh.
It's my problem.
Sorry for the inconvenience. Some issue with audio. And join with.
Hello, sir.
From here, madam.
Hello. Hello.
Hello. Hello.
Sir, hello, sir. 1 minute, sir.
Madam, I am reconnecting, madam. 1 minute, madam.
Okay, sir. Thank you,
Okay,
sir.
1 minute, madam. Be on the line, madam. I will.
Okay.
Hello.
Sir, you can share your PPT.
Hello, sir. Hello, sir. Sir, are you?
Ma'am,
Hello,
you
sir.
are audible. Amrita, ma'am, you are audible.
Okay, madam. Thank you.
Okay.
Hello, sir.
Madam. Madam.
Gouda,
Madam.
1 minute. 1 minute. Bar mile.
2 రోజుల మా
ಇದು
ఆఫ్టర్నూన్
ಆಡಿಯೋ ಒಂದು
కుదరట్లేదు
ಸ್ವಲ್ಪ ಬರ್ತಾ ಇಲ್ಲ ಮೇಡಮ್, ಇಲ್ಲಿ ಆಡಿಯೋ ಇದೆ.
ఎందుకు మేడం అట్లా చేస్తారు? ఓకే
ಕನೆಕ್ಟ್ ಅಂದ್ರೆ ಆ ಥರ ಸಿಗ್ನಲ್ ಕೊಟ್ಟಾಗ ಏನು ಹೋಗ್ತಾ ಇಲ್ಲ ನೋಡಿ, ಈ ತರ ಬೇರೆ ಸಿಂಬಲ್ ಅನ್ನು ಬರ್ಬೇಕು.
Sir, we are able to hear you, sir.
ನಾವು ಇಟ್ ಈಸ್ ಆಡಿಬಲ್ ಮೇಡಮ್.
సరే
Yes, sir. Yes, sir. It's very clear.
సరే మేడం.
ಹಲೋ.
Yes,
Hello?
sir. It's very clear,
ಇಟ್
sir.
ಈಸ್ ಆಡಿಬಲ್ ಮೇಡಮ್.
Your voice. Yes, sir. It's very clear. Your voice is very clear, sir.
ಓಕೆ ಮೇಡಮ್.
చెప్పండి. ఒక్క 2 minutes.
ಸೇರ್ ಆಗಿದಲ್ಲ ಮೇಡಮ್?
Sir, your presentation is also clear, sir. It's visible.
ಸರಿ ನೋಡಮ್ಮ, ಈಗ ಇಲ್ಲಿ ಬರ್ಬೇಕಲ್ಲ. Should we start, madam? Hello? Hello?
Yes, sir. We'll start, sir.
Okay, madam. Okay.
Hello, sir.
We'll continue. Madam. Start, madam.
Okay, sir. I'll just introduce you, sir, and then we'll start.
Okay, madam. Okay, madam.
Dear participants, welcome to the second session of day 3. Now we have Dr. Nagana Gouda to speak about various control techniques for wind power generation. Welcome, sir, to the session. Sir will be joining us in the afternoon for a hands-on session also. Before introducing Dr. Nagana Gouda to the participants, I would like to recollect our experience with sir in the first FTP, which was conducted offline in our college. Sir was the resource person for the first 3 days, and it was really wonderful to experience his enthusiasm and dedication in transferring the knowledge to the participants. We were really inspired by your positivity and energy, sir. Once again, thank you for those sessions. Let me introduce sir now. Dr. S. Nagana Gouda is a graduate in electronics engineering. He has done his master's in power electronics and PhD in non-conventional power sources, wind energy. He has got a vast experience spanning a total of 28 years. He was into teaching for 6 years in the initial years of his career. Then he worked as assistant engineer and then assistant executive engineer in Karnataka Power Corporation Limited for 13 years. He worked as technical officer and then assistant general manager in Karnataka Renewable Energy Development Limited, Bangalore for 7 years. From October 2010 to May 2019, Sir served as the Director of National Training Center for Solar Energy, Solar Technology, KPCL, Bangalore. He has published or presented a total of 4,550 technical papers. Sir is a Fellow of Institution of Engineers, India, and is a member of Indian Society for Technical Education, New Delhi, Administrative Staff College of India, Hyderabad, Karnataka Pradesh Krishik Samaj, Karnataka State, Bangalore, Sri Eriswamy Education Trust, Chellagurki, Bellary, St. John Ambulance, India, Karnataka State, Bangalore. Sir also honors the following. He is a chartered engineer. He is the Vice Chairman for Energy Conservation of Building Codes Committee in Public Works Department, Government of Karnataka, Principal Member of the Solar Thermal Energy Subcommittee in the Bureau of Indian Standards, New Delhi, Technical Committee Member of the Renewable Energy and Energy Conservation. Sir has received about 22 awards, which is a clear indication of the quality of his work. Thank you for joining us today, sir. Over to you, sir. Thank you.
Hello.
Sir.
Madam,
Sir,
shall we start, madam?
Yes, sir. Yes, sir. You may start. Yes, sir.
Okay. Okay. Very
Thank
good.
you,
Very
sir.
good morning, all of you. Respected principal, respected heads of the department, all the professors, staff members, on committee of this FDP program organized by the BVRD for technical education. So it is the responsibility of the government to provide the basic needs to society. The basic needs are providing education, medical, transportation, energy, etc. Among the basic needs, energy is the one which is the basic need for the overall development of the society. Today, the energy requirement for domestic, industrial, and other sector is increasing. But at the same time, we could not able to generate and supply as per because to generate electricity the conventional, we have some limitation, constraints, or commercial effects are there. As of today, the total installed capacity in our country is more than 380,000 megabytes. Out of which today we are generating more than 60% from the petrol, diesel, coal, etc. We are generating about 12% from the hydro, about 1.8% from the nuclear, about more than 25% from the non-conventional renewable energy sources. Whatever the resources are there, we have consumed more than 60%. Whatever the balances are there, it will not sufficient for maximum another 100 years. Because of the utilization of petrol, diesel, coal, etc., we are emitting carbon, other greenhouse gases into the atmosphere. As on today, we have already emitted nearly more than 400 gigatons of carbon, other greenhouse gases into the atmosphere. But as on today, we have observed only 200 gigatons of carbon, other greenhouse gases. Yet another 200 gigatons of carbon, other greenhouse gases, it is responsible for global warming, other negative impact on the environment. So in this context, renewable energy sources have received greater attention. In our country, as per 2011 census is concerned, more than 40% of people in our country, they don't have good electric supply. As per Government of India and Ministry Power is concerned, we have to electrify all households, all villages with local available resources, that is renewable energy sources. So in this context also, renewable energy sources have received greater attention. In our country, it is possible to generate more than 170,000 megawatts from the renewable energy itself. Out of which today we are generating about 89 to 90,000 megawatts from the renewable in our country. So development of the power plant will not sufficient. Parallel, we have to adopt energy conservation measures for sustainable development. For the overall development, we require energy. Parallel, we have to protect the environment. Thereby, our economy improves. So in this context, we have renewable adopting energy conservation measures for sustainable development. Madam, is it audible, madam? Hello. Hello.
Yes,
Hello?
sir. It is audible. Yes, sir. Yes, sir.
Okay,
It is
okay,
audible.
Madam, in this session up to 1:15, I will give the brief information about the various renewable sources, including wind, solar, hybrid system, madam. In the afternoon, I will take a completely on wind. Is it okay, madam?
Yes, sir. It's okay, sir.
In this session, I will give you all brief info about the renewable energy conservation, and also wind solar hybrid system, madam.
Okay, sir.
So
Okay,
in
sir.
afternoon, complete we take up the wind and its control system, hands-on training. Is it okay, madam?
Yes, sir. It's okay, sir.
Okay, madam. Thank you, madam. Thank you. So it is the response of the government to provide the basic needs of society. At the same time, it is also a responsibility of the society to conserve the energy resources and also protect the environment. So to generate 1 liter of electricity, we require 1 kg of coal with a requirement of 3.3 liters of water. Parallelly, we are emitting 1 kg of carbon, other greenhouse gases into the atmosphere. That is why whatever the natural resources are there, the air, the water and earth are not gift from parents. We have to treat it as a loan from our children. We have to safely use it and do it to our future generation as a loan taken from our children. It is mentioned in Veda. So we have to go for need-based consumption. That is, whenever required, you have to switch on. Otherwise, you have to switch off. That is the only solution for sustainable development instead of greed-based consumption. So for the overall development, we require energy. Parallel, we have to protect the environment, thereby our economy also improves. So in this context, we have to go for the tapping the renewable energy. It is very much required. Even though after utilization of non-conventional, every moment the energy requirement increases. But at the same time, we could not able to generate and supply as per the demand requirement, because to generate electricity from the conventional, we have some limitation, constraints or commercial effects are there already I have mentioned. So we are generating 5% from the renewable sources. If we generate more than 35-40% from the renewable, and definitely we can achieve energy independence in the energy sector. No doubt in Bangalore, Hyderabad, Delhi, Calcutta, we can get the quality supply. If you go to the rural area, are you getting quality supply? No. Why? It may be some problems will be there. Sometimes voltage problem will be there, energy cut will be there. One way, other way, we are facing a lot of problems. Our aim is to what? Our aim is to satisfy the customer need with what is happening today. So the conventional, for example, Karnataka, already we have installed more than 3,000 megawatt coal in Karnataka, Ballari and Raichur. In Karnataka, we don't have any coal resources. Whatever the coal we required, we have to get it from our neighboring states, Andhra, Bihar, Orissa, Bihar, or sometimes from the other countries. Because of the transportation coal cost, the cost of production increases. Second point, whatever the resources are, petrol, diesel, coal, etc., you consume more than 60%. Whatever the balances are there, it will not sufficient for maximum 100 years. Because of between petrol, diesel, etc., we are emitting carbon, other greenhouse gas into the atmosphere. That is environmental problem is there. If you come to the 4-point nuclear, total capacity in our country is more than 7,080 megawatt, 1.8%. But as per government of India and the nuclear program is concerned, there is a proposal is there to generate more than 10,000 from India. So then why we have to develop new generation? I have already mentioned, as per 2011 census concerned, we have to provide all electricity, all household, all villages, about 40% we have to provide electricity under village energy program. Parallelly, every moment the energy requirement demand increases, and we have to protect the environment, and increased safety is very much required, and inexhaustible conversion of energy and inexhaustible resources available, that is renewable energy sources. So in this context, renewable energy sources have received greater attention to energize remote rural areas with adequate available, least impact on environment, ecology, and suitable for a decentralized variety of application. In our country, the total transmission is more than 30-35%, and the decentralized generation distribution, it is possible to drastically the transmission distribution losses also. In our country, as on today, the total installed capacity is more than 384,000 megawatts. Out of which today we are generating more than 60% from the petrol, diesel, coal, etc. We are generating about 12% from the hydro, about 1.8% nuclear, about 25% from the non-conventional renewable energy sources. In our country also, we are generating more than 96 to 7,000 megawatts from the renewable energy in our country. In Karnataka also, though the potential is there, it's possible to generate more than 30,000 megawatts. Today we are generating more than 15,000 megawatts renewable in the state of Karnataka. Similarly, plus or minus will be there in the other states also. So in Karnataka also, this is the ongoing new existing power plant in the state of Karnataka. So government of India, they have come up with various policy programs. Whatever the policy program framed by the government of India, we the concerned state, it may be Andhra, it may be Telangana, it may be Karnataka, Orissa, whatever the state, same guidelines policy we are following. So as per the guidelines issued by the government of India, we the state following the same guidelines. So based on the policy guidelines issued by the government of India, we have brought out Karnataka renewable policy in the December 2009. Under that policy, over a period of 5 years, how much energy we can generate from the waste renewable energy sources. So this is the target we have fixed over a period of 5 years. This is similarly minus in other states also. In the almost all conventional, the initial investment is very low, but as the time passes, the cost of production increases. Whereas non-conventional renewable energy sources, initial cost is very high, but as the time passes, the cost of production goes on decreasing. For example, during 95-96, installed 1 megawatt power plant, it was more than 45-46 crores per megawatt. So when we have established the first grid connection system in 2009 in Karnataka, it was more than 20 crores. Today, the investment cost per megawatt from the solar, it is about less than 3 crores. Because of the investment cost is high, government is giving subsidies of loan depreciation, other kinds of benefits. But as the time passes, the cost of production goes on decreasing. So we have to go for energy management. What is energy management? It comprises of accountability, responsibility, sincerity, and also honesty, providing natural justice. This is called management. So we are in the energy sector, we are calling energy management. So as per Energy Conservation Act 29 September 2001 is concerned, we can save more than 40,000 megawatts without investing a single life. How? By adopting energy efficient management, mainly by giving proper awareness among the public, among the staff, in addition to adopting all these parameters. So these are the various sustainable energy, whether it is a conventional, non-conventional, nuclear, etc. So once we generate the power, the transmission distribution is common for all the resources, whether it is from solar, hydro, thermal, nuclear. But once we generate the power, then transmission distribution is common for all the resources. So this is the energy map of India. This is existing, ongoing, new proposed power projects in the grid connected power projects, power transmission grid lines in our country. In our country, there are 5 grid systems, not western, even not comprised of 6 states. So in our country, the TC lines as well as AC lines are available. Earlier we have only decentralized generation. Today we have decentralized generation distribution system, and that this system, it is possible to reduce drastically the transmission distribution losses also. So in earlier, before 2003 in our country, we have only 1 or 2 departments in almost all the states. After after Electricity Act 2003, each state the unbundled with 1 or 2 generation transmission distribution with the transmission separate, generation separate, including distribution also separate corporations. So in Karnataka, as per 2003 Electricity Act in Karnataka, now there are 9 departments existing in state of Karnataka in the energy department, in the energy sector. Similarly, in other states also 4-5 departments existing. So this is the existing power projects in state of Karnataka, the ongoing new power projects in state of Karnataka also. So I have already mentioned, every moment the energy requirement increases, but at the same time we could not able to generate and supply as per the demand requirement. For example, to generate electricity from the hydro, we have some limitations or constraints are there. What are the limitations? So interstate disputes, internal agitation, submersible land, getting clearance. And getting clearance is not a problem. Only thing is rehabilitation. People who are living in that area make alternative. This called settlement is required, and the environmental problems will be there because of the cutting trees. That is the one problem is there. Now, to generate electricity from the thermal also, we have some limitation. Commercial effects are there. In the thermal, after utilization of coal, what we are getting waste. So disposal was a major problem, but that is not a major problem. Whatever the ash content we are getting, that we are using for making bricks, roads. They are also using cement factory. Only thing is emission of carbon, other greenhouse gases, and the cost of coal goes on increasing because of the transportation, other coal cost, and because of the emission of carbon, other greenhouse gases, there is environmental problem is there, and the cost of production also goes on increasing as the time passes. In nuclear also, as on today in our country, the total installed capacity of nuclear is about 6,780 megawatts, about 1.8%. But Government of India, as per Government of India, the nuclear power is concerned, there is a proposal is there to generate more than 10,000 megawatts between 2010 to 20. Here the problem is with existing technology, disposal of the used radio material with existing technology, and environmental hazard risk, that is not a major issue. Technology are also available. So in our country, over a 10, 20, 30 years, what is the power requirement? So development of the power plant will not sufficient. Parallelly, what is the transmission grid required in our country depending upon the power project establishment. So what is our national objective? Our national objective is electrification of all households, all villages with local available natural resource, that is renewable energy sources, as per the Village Energy Security Program of Government of India. And GDP can leave it gradual reduction. Wherever the losses are there, at least we have tried to minimize the losses. And demand side management, we have to adapt as per Energy Conservation Act 29 September 2001. Development of the strong infrastructure is also equally important. Some issues are, if you go to the northeastern states, some problems are there because weaker state. So energy cuts will be there, resources for other problem. We have to give more importance in the northeastern state. Parallelly, some challenges. What are the challenges? Now the loss is more than 30-35%. So at least we have to reduce the transmission distribution and the decentralized generation distribution and the electrification of all households, all villages with local available natural resources, and development of the strong infrastructure, adopt energy conservation measures, all as per Energy Conservation Act. Parallelly, we have to give more importance on R&D in new emerging technology like clean coal technology, nanotechnology, hydrogen energy, superconducting, thin film technology, including transmission, distribution, generation. Also, what is the solution for coming out of this situation means conserve electricity, conserve fossil fuel, save water, allow nature to maintain ecological balance, save environment by tapping maximum use of natural inexhaustible resource, that is renewable energy sources. So in this context, renewable energy sources have received greater attention. What is the what are the various renewable sources? Solar, wind, biomass, biogas, biofuel, mini hydro. Actually, hydro is a renewable energy because of the administrative sake only. More than 25 megawatt comes under conventional, less than 25 megawatt comes under renewable energy. It is renewable energy. Generation right now possible in sugar factories, but it is possible to generate electricity wherever the boilers are using. So in the co-generation, the main product is sugar. After crushing the cane, what we are getting waste bagasse, using that bagasse, reheat the existing steam, will what the super steam. That is the concept in the co-generation concept. But it is possible to generate wherever the boilers are using. Ocean, tidal, geothermal, still it is R&D only in our country. Other country also already geothermal and fuel cell, it is commercial plants are there. So these are the advantages of renewable energy sources. Receive greater attention to energy remote rural areas with adequately available, least impact on environment, ecology, and ideas for decent application. In accessible areas very become handy. The cost of generation also goes on decreasing as the time passes. It is all eco-friendly power projects. In the renewable energy also we have some limitations are there, constraints. So what are the constraint limitations? Solar, biomass, coal generation, mini, micro, etc. In the solar, it is daytime only possible, night time not possible. During rainy season, cloudy season, generation somewhat limited. But in our country, more than 80% of our land is suitable for tapping solar energy. We are in the northern hemisphere. Above the equator 40 degree, below the 40 degree, it is called solar belt. We are in the northern hemisphere. Our country will start from 8.4 degree Kanyakumari to 37.6 degree Jammu and Kashmir. So we are in the northern hemisphere, solar belt. More than 80% of our land is suitable for tapping solar energy. We are getting 4 to 7 kilowatt hour per square meter per day. That much energy we are getting in our country. In average, also, but in the solar, if you want to use it night time, some storage option required. That is one major problem. And next, you come to the biomass. It is also raw material cost based only. Co-generation only in sugar factories, but it is rainy season only. Solar energy. The solar energy, the sun inexhaustibly brings enough energy. That means if you generate electricity from the one day sunshine or insolation, what you get sunshine? If you generate electricity from sunshine, provide electricity for whole world, tremendous energy we can generate from the one day sunshine or insolation. But are we getting that much of energy every day? Are we tapping that much? It may be a cost or it may be a technology. So solar energy is responsible for other kinds of energy. If solar is not there, nothing will be there in the universe. So solar energy is responsible for other kinds of energy. That means from the, so if without solar, nothing will be there in the universe. So sunlight, from the sun, we are getting 5 types of radiation. The 5 types of radiation: cosmetic, gamma, ultraviolet, ABC, and also visible infrared. And application, solar, water, solar cooking, other industrial application. So whatever sunlight we are getting from sun to reach Earth, we require 8 minutes 30 seconds. Oh, this is the spectrum of light. This is the spectrum of light. Madam, is it audible, madam?
Yes, sir. Yes, sir. It is audible.
Okay. Okay. So whatever the heat radiation we are getting and how much energy we are getting sun, it means we are getting 38 watts per meter. Our solar panel will work only 1000 watts per meter. We are getting 36 watt per square meter from the sun, but our solar panel will designed as per 1000 watts per square meter. And during rainy season or rainbow, you can see at the angle of 40-42 degree. And these are the time required to reach the various planets. From the whatever the light we are getting sun to reach Earth to 8 minutes 30 seconds. Similarly, to reach various planets, this is the time required. For example, Pluto, it requires 8 minutes, 8 hours 30, 8.3 hours. That means Kanyakumari to 37.6 Jammu and Kashmir. So above the equatorial 40 degree, below the 40 degree belt, we are in solar belt. Solar radiation in our country is better than other countries also. Better than other countries also. So there is a change weather from one place to other place. What is the reason? There is a temperature variation, pressure, humidity, wind speed, all those things. What is the reason? Why? Because of unequalating of Earth. From the sun, we are not getting equal light and heat. So it varies from place to place. Because of the unequal heating of the Earth, we are getting various changes from place to place. There is a changes in the sun radiation, temperature, pressure, humidity, wind speed direction, etc. So whatever the light we are, so how much of 23 was reflected back into the atmosphere. Solar radiation in your country is better than other countries. So we are in solar belt, maximum 80% of our land we are getting in our country, maximum 9 hours in a day. If you go so this is solar power in India. So our 7 kilowatt hour per square per day. Even if you go to the certain area, even 365 days will get from 6 to 9 hours in a day. But it is average in our country. So to get any power plants, solar or wind, we require certain data. To get the data, solar or wind, etc., Government of India, they have established solar monitoring stations at various places in our country. By through the earlier it was Center for Wind Technology, now it is a National Solar Wind Energy Center for Wind Energy Technology at Chennai. So they have installed about 125 solar monitoring stations at various places in our country. From that solar monitoring station, we are getting 26 parameter. The 26 parameter: temperature, pressure, wind speed direction, including direct radiation from the sun, reflected, diffused. These are the data we are getting from the solar monitoring stations. So in Karnataka also we have installed at 5 places. I was in charge at the time. We have installed in Karnataka, Bijapur, Ballari, in Andhra Pradesh, Tamil Nadu, Kerala, Telangana, everywhere they have installed in our country by the Government of India. So in Karnataka also, except the Malnad area, partial Malnad area, more than 26 districts are sort of tapping solar energy. Even Telangana, Andhra also we are getting summer, winter or monsoon also getting maximum sunshine suitable for generation of electricity. So there are two things, global scenario, why required in India. In our country, more than 40% people don't have real supply. We have to provide electricity supply by tapping renewable energy. So insulin cost is India. Why we have to go for global scenario? In the global, more than 60% people they don't have grid supply. So it is also responsible. For example, we are all accountable for our parents. We are all accountable for institution where we have studied, but we are all accountable for our country as a citizen of our country. But as a human being, we are all accountable for whole world as a human being. With this, in the whole world globally, more than 60% people though don't have grid supply. It is also our responsibility to provide electricity. So there is shortage of energy is there. We have to protect the environment and also we have to protect electricity. As a human being, we have to concentrate globally. So from the solar energy, we are getting two types of energy. One light energy and heat energy. From the light energy using solar photo technology, directly we can generate electricity using solar photo technology, and tapping heat energy also we can go for thermal applications. That means solar water heater, solar cooking, other industrial applications. So what is the solar photovoltaic solar panel? What it consists of? It is a semiconductor material. It is a p-type, n-type material. When little light falls in material, it produces holes and electrons. When little light falls in material, it produces holes and electrons. Movement of the holes and electrons, it is nothing but the electricity. That is the concept in the solar PV model. So it is a semiconductor material, p and n type junction. When little light falls in material, it produces holes and electrons. Movement of the holes and electrons, nothing but the electricity. That is the concept in the solar technology. The concept in the solar technology. Silicon solar well, you can see photovoltaic. So when little light falls in material, it produces holes and electrons. Movement of the holes and electrons, nothing but that is the concept in the solar technology. So in our country, right now, we are not manufacturing raw material vapor as per solar cell is concerned. Whatever the raw material vapor we are getting from the other countries, we will bring the vapors, we will make the cell by the 19 companies in our country. Rest they will only model manufacture. They will bring the vapor, they will make the cell. About 19 companies in our country. Rest only model manufacture. They will bring the cell, they will make the cell. So right now we are not manufacturing solar vapor is concerned. So this is the various process manufacturing the solar ingots, solar vapors, etc. So I was also visited during tenure George Bush in USA. We visited all these manufacturing plants, how they will make all those things. It is nothing but the silicon, only it is nothing but sand. So these are the various process manufacturing the solar cell. So what is the solar PV model? It consists of solar cell over which ethyl vinyl EVA sheet. Front again glass protection, back also EVA sheet, again back sheet along with the frame and also contactors. So it is a solar cell over which ethyl vinyl sheet, EVA sheet, glass protection, back also EVA sheet and back sheet along with junction box frame along with aluminum frame. You can see thin model. So what is the specification of this cell? As per specification cell, we can come at two types. One is, if you come to the physical dimension, it is a micron thickness with 6 inch by 6 inch. If you come to the electrical parameter, one cell may produce 0.5 or 0.6 volt depending. If 0.5, 0.6 means it may be 4 or 5 watts, depending on quality. So I want 6 volts, I want 10 volts, I want 12 volts. How to connect? Using Kirchhoff's voltage law. By series connection, we can increase the voltage. Using Kirchhoff's current law, by parallel, we can increase the current. Thereby, you can go for watt to kilomegawatt. So that is the concept in the solar technology. For example, when solar cells models are connected in series, the voltage increases. When connected in parallel, the current increases. Thereby, we can go for watt to kilowatt megawatt. That is the concept in the solar technology. Solar PV model connected in series. When connected in series, we can increase the voltage. When connected in parallel, we can increase the current. Thereby, we can go for watt to kilowatt megawatt scale. That is the concept in the solar technology. So, for example, similarly, these designs are required while designing the grid connected megawatt plant. When connected in series, we can increase the voltage. When connected parallel, we can increase the current. So this is the concept. Already you are well aware of these things. So the cells are connected model series only. In the model, cells are connected in series only. There is no question of parallel. The model can be connected parallel or series depending upon the design voltage requirement, current requirement, but the cells are connected in series only in the model. The model can be connected series parallel depending upon the design requirement. So this is the cell connected in series. The model can be connected, that is called array, series or parallel depending upon the requirement. So this is the structure of the solar panel. Cells are connected series only. Right now there is the five technology existing as on today. One is crystalline. In crystalline we have two technology, mono and poly, thin film amorphous phosphorus, and like cylindrical type, silicon type, and concentrated for. There are five existing, but most commercial only crystalline, thin film. The most advantageous is the way the temperature very high, better to go for thin film, but the drawback is 5 to 6 years. Whereas crystalline, we have two types, crystalline, mono or poly. The difference is mono, the crystals are aligned uniformly. In the poly or multi, which is scattered. That is the difference. Rest of the one, the life of the equipment is 25 years. This is cylindrical, still it is R&D only, and concentrated here and there installed, still it is R&D only. This is a spectrum of the light. So nanotechnology, still it is R&D only. And the second generation multi-junction, still it is R&D only. Third generation multi-junction cells, it is also still it is R&D only. Future generation, this is also still it is R&D only. Printable cells type and all organic, still R&D is going on all these nanotechnology, including interpretation, nanostructure, etc. Still it is R only. Decentralized, still it is R&D only. Different models are available. For example, cloth lined foldable fixed type solar panel, even plastic rollable type also available, including ribbon type also available. So where you can ribbon type, you can fold it wherever you want, you can spread it, you can generate the power, again you fold it. Ribbon type also available. So instead of going for rooftop zinc sheet asbestos, you can solar panel itself rooftop under building integrated photo technology. These are the different up to even 5 watts up to 600 watt solar single model also available right now. Many advantages are there. So when sunshine comes, it will start generation. There is no delay. So absence of there is no wear and tear. There is moving parts. There is no moving parts. Ability for longer life, power level you can go by more integration using Kirchhoff's voltage law, using Kirchhoff's current law. By series parallel combination, more possible, you can go per watt to kilowatt megawatt scale. So absolutely there is no maintenance. Depending upon the dust area only, we have to clean the solar panel. There is no pollution, longer life, more than 25 year life, highly reliable. There is no recurring cost. Rapid response, wider power, you can go per watt to kilowatt scale, easy to fabricate. Suppose you want to install 1 kilowatt, within 15 minutes you can install and generate the power. To install the 1 megawatt solar, within 2 months you can install, you can generate the power. Even wind we require 3 to 4 months. Even hydro we require 5 to 10 years. Even nuclear 5 to 15 years we required. Even thermal we require 3 years. But here the gestation period, within 2 months you can install, you can generate the power. And also it is amenable to site condition. Irrespective of the site condition, it is possible to install, you can generate the power. So here northern hemisphere, you put it in south facing, you can generate more energy. At what angle? Depending upon the latitude of particular place, you can install, you can generate the power. That is how we are going to install. We are northern hemisphere, you put it in south facing, you will generate more energy. At what angle? Depending upon the latitude of the particular place. So then what is tracking? Depending upon the sun movement, you can go for tracking east-west, single axis, east-west, north-south, that is dual axis. You can generate more energy, but tracking also, you can generate, no doubt, you can generate more energy. At what cost? The cost also increases, wear and tear will be there, maintenance also required. It is all eco-friendly power, already I have mentioned. Applications, many applications are there. So once we get the power, you can use it for water pumping, radio, beacons, community, cathode, weather monitoring, battery, cooking, distilling, eating, distillation also it is possible. Process heating, refrigeration, so many applications are there. So for the development of the renewable energy in our country, by the Ministry of New and Renewable Energy, and implementation of energy conservation by the Government of India, Ministry of Power, they have come with various policy program. Based on that one, they have come up with the Jawaharlal Nehru Solar Mission, and that mission they have very extended strategy, policy, incentives, R&D, tax holiday, they have extended. So based on the in Karnataka, not only in Karnataka, other states also come up with the policy programs. There is one program is there under Adarsh Samsad Grama Yojana. In the Adarsh Samsad Grama Yojana, they have tapped the solar or the renewable energy in that MP constituency. They have to select one village in their MP constituency. They will get 1 crore under village energy program under Adarsh Samsad Grama Yojana. They have to tap the renewable energy in that village. They have to provide electricity under Adarsh Samsad Grama Yojana. They will get 1 crore in their constituency. They have to select one village. So these are the smart villages, off-grid development for various household, food, health, etc. So these are the various application rules. Actually, once we get the energy, whether it is urban or rural, that is immaterial. It is common for all the requirement. So state level energy park, this is one demonstration project. You will get 75% from the government of India to demonstrate various renewable energy sources. And there is one more is the district energy park. You will get 50% in the district level. There is also demonstration project is there. So earlier we have only solar city, now come up with the smart city. In the solar city, smart cities, so these are the renewable energy devices systems we have to implement under smart city or solar city programs. Apart from that one, we have to implement energy consumption measures by, instead of going for in-kind tube light, we have to go for LED, CFL and electronic choke and energy efficient systems. We have to adopt under energy conservation measures based on the guide issued by the government of India and the smart city for them. So the major programs is grid standalone urban rural areas. But now it is required. Earlier they used to give 30% subsidy as well as 5% soft loan. You can avail any one. Apart from lighting system, you will also get subsidy for the solar water heater, solar cooking, other industrial application. From this slide, you can make out more than 40% people in our country they don't have supply. It is also a responsibility to power electricity. For that, the government of India come up with the village energy sector program. Under village energy sector program, we have to electrify all households, all villages with the local available natural resources. So this is the smart village off-grid development. So various applications are there. So solar village where grid penetration not possible, you get 90% subsidy, 10% from state you can freely get to the solar systems where grid penetration not possible. These are the systems we have installed at various places. So one home lighting system is there. Will got 40% subsidy through NABARD, through local banks, 1 light, 3 light, 2 light, 3 light, 4 light with fan TV. You will get 40% subsidy. Solar lanterns are there. So you will get free equipment where network belts are there. Solar lantern, space, remote areas, solar advertise hoardings, communication applications. So in our country, in almost high school, they have computers, but there is no power supply. How to operate? So that is why solar power packs are available, 1 kilowatt, 2 kilowatt. They can install in their schools. So they can go for operation of the computers. That is also possible. Government works. So almost in our country, almost a primary has to be in the rural area. How to preserve the medicine? That is why to preserve medicine, solar refrigeration, air conditioning system also available. So hospital cleaning, sterilization also it is possible. It is also possible. Solar street light, solar street lights, garden lights, street light we have installed at various places in our country. So these are the various systems of the solar street lights also available. Solar street lights also available. So from the solar we are generating only DC supply. Through charger you can charge the battery, or if you want to DC directly you can through charger you can the DC loads, or if you want AC through inverter you can also get the DC directly, or if you want AC through inverter you can also get the AC supply through inverter. So this is a standalone system, DC system standalone. If you want to AC through inverter, you can also get the AC. So it is a directly connected through charge controller, through battery, and if you in a system you can get AC DC also. It is possible. So the concentrated photovoltaic in a single system, you can get generate electricity as well as you get an hot water. That is hybrid system. Still, it is R&D only. There is one net metering concept is there under Government of India. For example, in your engineering college, you can install in the rooftop solar power plant. Whatever the power generated, you can use it for your day-to-day requirement in your college. Excess you can generate. If you excess generated, you can export to the grid under net metering. For example, during Sunday, general holidays or vacation, whatever the power generated, you can export to the grid under net metering. For that also you will get some revenue under grid connected rooftop system with net metering. That is also possible. There is one more system is there. Suppose in your engineering college, almost all they have computers. They want to get they required in the uninterrupted power supply. Already UPS system existing already existing. So integrate solar panel with a solar panel with existing system. You will get the this solar power plant becomes solar power plant. Thereby the battery life also increases. So charging discharging losses can be reduced, and also investment on batteries already inverters already invested. So the investment cost will reduces. So life of the battery increases, the losses are reduces. So it is a very good option for the wherever the UPS system, you better integrate with solar panel. It becomes the solar grid connected power plant. It is very good system. So this is the schematic diagram approved by the Government of India through net metering system. This is also one system we have installed in our training center, directly connected to the grid inverter or through UPS system, through converting DC to AC, directly can go for UPS system. So this is one system we have installed in our Vidhan Sabha in Karnataka without batteries. So here you can see it is amenable to site condition. Irrespective of the site condition, you can install, you can generation, whether it is a wall mounted, grid connected, etc. So this is one how to design. Sir, I want to install 1 kilowatt system. What is the cost? 1 kilowatt, absolutely no problem. The cost without battery, it may be a 40,000. 40,000 without battery. If you want to battery 1 or 2 battery, it may be 10 or 12,000, even 60,000. You will get 2 batteries, 1 kilowatt system. So for 1 kilowatt system, you record area of 10 by 10 square feet area. You can generate, if good quality, you can generate 5 units per day. The cost is 40,000 without battery, with battery 60,000. Area required 10 by 10 square feet area, and also you can generate 5 units per day per kilowatt. That is okay. But suppose I am having 4 lights, fans, TV, etc. What will be the cost? It is very difficult to give the cost estimation. Better to go for what are the appliances are there? Tube-light, fan, refrigeration. So what is the number of, what is the wattage, how many numbers you are using, what is the total energy consumption per day? On that basis also we can design the system. So you can get the cost based on the kilowatt, or you can design the system based on load requirement. Accordingly, you can get the cost estimation. So this is the one net metering concept, how to connect things. So solar thermal technology. In the solar thermal technology, so you can go for solar drying, cooking, cooling also it is possible. So in the Swiss, they have installed more than in the year in the 18th century for tapping solar energy. In the USA also they have tapped solar energy for hot water purpose. Even before 1900s they have tapped solar for printing other purpose. So in the solar we have 2 types. One is evacuated glass tube ETC, and also one more flat plate collector. So many applications are there. Once you get the hot water, many applications are there. You can go for breweries, distilleries, dairies, textiles, even textile, yarn industry, process, brewery, industrial. Many applications are there. They're tapping up heat energy. Solar water pumping up to 5 kilowatt, 5 HP, you can get the subsidy from the Government of India through state electric supply companies. Here the only thing is the water requirement and also depth of the water. Accordingly, you design the system, you will get the subsidy. You can use it for irrigation or drinking purpose. Even during rainy season also, if solar power plant solar pump not required, you can generate the power. That power can use it for local, or excess you can export the grid under net metering. That provision is also existing. Solar drying of the agricultural products, drying of the chili, mango, tea, ground nuts. This is also possible. Solar space heating, even solar wall application, tea, coffee, timber, rice, chili, grapes also it is possible. Solar swimming pools also available, will also get subsidy. Even instead of going for AquaGuard, you can go for solar safe drinking system also. It is possible. So this is the one system, portable pure drinking water scheme is there. So desalination seawater, potable water. This one system installed 100 million liter per day. This system installed in nearby Chennai. Whatever the potable water they want to get, they will get the seawater only. After desalination, they will get to potable water. So this is nearby Chennai. They have installed 100 million liter per day. Desalination plant installed nearby Chennai. They will get potable water from this plant only. So we can go for direct, indirect methods also available. So earlier in our not only in our country, Karnataka, in other states also, there is no pure drinking water scheme. So there was one program organized by the government of India in Hyderabad. At that time, they have come up with one solution. So for pure water drinking system, they have to go for solar energy. As well as the lifting water. There is one hybrid pump is there, manual, even state electric board, as well as solar. You can go for this kind of system. Solar water supply in schools, other rural areas also is possible. Even solar stills for distilled water also it is possible. So this kind of R&D is going on in Pondicherry University under Green University. That is there they have tapped solar energy for steam. Other dryers R&D is going on for distilled water. Effluent treatment application also they have installed. R&D is going on. Solar cooker. In solar cooker, we have two types are there. One is commercial as well as domestic. In the domestic, 5 to 8,000 you will cost will be there. You will get 45% subsidy. Even commercial also, for example, in Tirupati, for example, in Sai Baba at Shirdi. In other place, they install solar cooking system. So in the domestic, we have this type the cost is 5 to 8,000. You will get 45% for subsidy. Even commercial also will get 45. Mills. You can also go for this kind of system. It is possible. In Karnataka also one temple is in Karnataka, Tumkur district, Ediyur, Kunugal district, Taluk, Ediyur. There the complete they have solarized the cooking purpose, even solar building. 24 hours they will get hot water, etc. So in Karnataka we have installed the one boss for canteen purpose, and ITC Royal Government also they have installed for the laundry purpose. Laundry purpose they have installed, and also they have installed in Bijapur Sainik School. Bijapur Sainik School they have installed. So this is one system installed at Bijapur Sainik School. 500 students are there. They have installed the solar cooking system. Solar traffic signals also available. Solar traffic signal system. And also solar fencing also available. Solar fencing system. So drying up the agricultural, that is leather industry, tea industry, they have installed for the drying up agricultural products. So no doubt wherever the space you install, you can generate the power. If you go on installing at various places where you will get a space for growing up the agricultural products, it become one day constraint. That is why you can go for canal based. Wherever the waters are there, you can go for floating type solar power plant. Thereby you can save the land, you can reduce the evaporation, and also cost will also come down. So floating type solar power plant also very good system. Now it is under demonstration installed at other places. In Kerala they installed 500 kilowatt near Wayanad floating type solar power plant. But still it is here and there they have installed for demonstration. That is going on. Solar farms. Solar farms. So this is one distilling system there. So solar panels available from 5 watt to 6 watt single models also available for rooftop system. So charge controller also available, two types. One is pulse width mode technology as well as MPPT technology. Even you can go for up to higher capacities also available, dependent technology you required. And also inverters are available, unidirectional, that is grid connected, bidirectional, as well as the UPS system also available. For net metering system also available. That is MPPT technology only available. Now single inverter available, even 400 watt to even 2000 kilowatt single inverters also right now available. Grid connected, bidirectional also available. Batteries also available. In the battery, two types: primary batteries, secondary batteries. Primary battery used and through, secondary battery chargeable. In that we have two types. That is a maintenance free battery. But as per Government of India, for the solar technology, they have insisted you can go for maintenance type secondary battery, maintenance type batteries. That is tubular lead acid battery only they will recommend. Next, cables. In the cable also we are available: AC cable, DC cable, control cables, mounting structure also available. So meters are available: AC meters, that is the DC meter, AC meter, voltage, frequency, even net metering, tri-vector meter also available. Different meters also available. So this is a junction box. So these boxes are required, that is the DC distribution, array junction or string monitoring box in the grid connected design. So even connect, what is the panel connecting from one panel to another? There is the MT4 cable also available. There is plug and play system also available. So in the grid connector, solar grid connector, major component: solar panel, grid tie inverter, as well as grid. In that DC from solar panels to grid, there is a DC bus will be there, array junction box or DC distribution box. Next from DC converting AC to DC, DC to AC, from AC to again grid connected AC bus are available. In that we can go for this one, that is HT, LT system. This is one system. Current system is a small system for the inverter. Converting, suppose if an individual building there, you can DC to convert AC connected directly to, that is the string inverters also available. This is the string inverter system, that is smaller system, up to 100 kilowatt you get this string inverter system. Suppose you want to go for higher capacity, these are the higher capacity. So it converted DC to AC from low LT panel, HC panel, stepped up to 400. Normally the output is 4 or 60 depending upon the HD panel also available. So this is the various schematic diagrams, line diagram. So various losses will be there. How to minimize the losses? These are the already standards are available. So by proper selecting the quality of the material, you can go for reduce the losses. So here you can see. So there is a losses will be there. If any shadow losses will be there, that we have to make the shadow free area. So there is a lot of shadows are there, that we have to reduce the shadows. So this is system. See how they have installed. So it looks very ugly, is it not? So that is why you go for a precise. There is not be any shadow effect, totally shadow free area it is required. So from this slide you can make solar radiation. So there is a 100% installation, you will get the solar radiation. If any shadow effect will be there, the generation will reduces. So you have to go for shadow free area. So suppose this is fixed mounting, directly you can focus to the sun at different at a particular place, you can generate more energy. So tracking also from east to west also proper tracking can generate more energy. So even summer, winter also there is a change in the direction of movement from east to west. So accordingly you have to design the shadow free area it is required. So what is the distance required from one row to other row? We require minimum 2 times the height of the row area. Then we will not get any shadow area. Summer, winter also will not get any shadow area. So that is very important. So in summer, winter also manual adjustment also you can generate more than 10% more energy. That is also possible. So tracking you can go for single axis east west, dual axis east west north south also it is possible. So mounting structure. So this is a customized panel you can install in the canal based or in the agricultural land. Instead of going for this polyhouse, you can go for instead of polyhouse, you can install the solar panel. For example, it is a polyhouse. Instead of polyhouse plastic sheet, you can go for 10 feet height. You can install solar panel. Thereby, you can generate energy. You can save the space. Parallelly, the water requirement to grow the horticulture product reduces, and also yield also increases. Whatever the power generated, you can use lifting water for irrigation or drinking, or you can generate electricity. You can supply to the grid. You will also get revenue. So your advantages, you can save the space. You can get the revenue. So water requirement reduces, and also yield also increases. Many advantages are there if you go for instead of polyhouse this solar panel. So you will get the solar low temperature, high temperature also it is possible. So it is different technology is also available. So heat energy, heating water, getting steam. You can go for thermal applications. Heating water, getting steam generation. That is one concept is there. Tapping heat energy, heating water, getting steam. In a Raichur thermal plant, what we will do? We will bring the coal, heat the water, getting steam, feeding steam to steam generation. So same concept is here. Tapping heat energy, heating water, getting feeding steam generation. You can also generate electricity. That is under thermal mode. That is also possible. So solar tower also available. Tower type, dish type. In Karnataka also we have installed at various places as per the government of India under demonstration systems. So as per Energy Conservation Act 29 September, we have brought out Energy Conservation Act in our Karnataka, similarly in Kerala, in Hyderabad, that is Telangana, in Andhra Pradesh, in others they have brought out Energy Conservation Act. Under that act, we have to adopt energy conservation measures under energy conservation building codes. So any new building, they have to design, they have to construct in such a way, drawing more than 30-40% point, they have to avoid, they have to design, they have to generate in the building itself by tapping solar energy, wherever it possibly possible, you can use small wind energy also. Instead of going for rooftop, you can use a solar panel, thereby you can generate electricity, whatever the electricity generated, you can consume in the local area. This is also one concept under Building Internet Photo Technology under Energy Conservation Act. See, they will install the rooftop. So instead of going for the jinxes as you can install solar panel as a rooftop. That is also possible. How to design this? See, there you can install. So wind energy I will not take, I will take up in the after. Solar small up to 100 kilometers. More than 3 blade tunnel, though it is renewable because of less than it comes under by small meaning, etc. We also classifying around the small height or based on the type of the water, dam based, depending upon the whether it is a canal based or dam based or the run of the river system. So these are the various parts in the hydro system. That is a penstock, turbine, generator, even outdoor unit switchyard, etc. Though this is a turbine, rotor, generator, etc. Because hydro is up to 100, but you will get subsidy from the government. You can generate the power. Under net metering also it is possible. Small system where water is flowing, you install, you can generate the power. This system you will get the subsidy through state nodal agency, you can apply. So where the drainage water flowing, you can install generator, you can generate the power. Because also it is possible. And animal power generation. Animal driven means where free animals are available, you can go for generation. Free animal generation also it is available. Biogas energy, that means you can generate directly using cow dung, etc. And methanation formation also possible. You can go for generation, power generation. So cow dung, if it is not our
Hello, sir. Same
level, it is a urban waste or insecticides, chemical also it is possible. Even in waste, industrial waste, raw material, even rice, coconut fronts, branches, paper mills, grain, everything is possible. Other way it is possible. So if waste is not available, you can go for energy plantation. Wherever the wasteland is there, under energy plantation, you will also get subsidy growing up these biomass plant. It is a carbon neutral system only. So waste oil recovery also possible. Waste heat also it is possible. And co-generation already mentioned, it is possible in sugar factories because the manufacturing sugar, main product is sugar. During manufacture already steam is existing. You will get the super team. That is a concept in the co-generation. Plant what to do, coal, heat the water, getting steam generation. That is possible, but it is possible to generate wherever the boilers are using. Biofuel, growing up the Pongamia, Jetrop also it is possible. You will get the oil, seeds, crushing of seeds, you will get oil. This oil is nothing but equivalent to diesel only. That is biofuel equivalent to diesel. That is biodiesel. Growing up the you get the seeds oil. But oil is nothing equivalent to diesel only. You can go for transport. So non-renewable also it is possible. In an area you will get tar sands with oil sale. Utilities are R&D only. So ocean trade geothermal is still it is R&D one in our country. For example, tidal energy, still it is R&D only in our country, tidal energy. So this is tidal energy, one system installed in Karnataka at nearby Udipan, Vijayakumar. Depending upon the tides, it's possible to generate electricity, but still it is R&D only in our country. In our country. Wave energy, this wave energy, one system in India in collaboration. Particular when they installed wave technology from the government of India in collaboration with Green University, but still it is R&D only. Depend where air pressure, that air pressure rotates the turbine. Still it is R&D only. Geothermal areas in our country, various geothermal areas are there, but still it is R&D only. Whereas in the US, in a Salt Lake area, I was also visited during tenure Jarbus. One Salt Lake area, there they are generating more than 5 to 600 single location. So once you rig up the gear, water rig, they will get water like this. It is not a water, pure steam. Without any further process, they feed to steam generator. They generate electricity in Salt Lake area in USA. In our country, those sites are there, but still it is R&D only. The final solution is water. It is a combination of oxygen, hydrogen. Hydrogen is best for transportation generation, but still it is R&D only in our country. Whereas in USA, they're generating electricity. They are using for transportation as well as generate electricity using fuel cells. But in our countries, still it is R&D only. So development of the power plant will not sufficient. Parallel, we have to adopt energy conservation measures for sustainable development. So how much energy can we reduce? Why we are not reducing? It may because of awareness, motivation, etc. For example, instead of going for conventional geyser, if you go for solar water, how much peak shortage, peak demand we can reduce. In the evening also lighting system, instead of go for in-conditioner or too light, if you go for CFL LED, how much energy we can reduce. For example, night lamp, what we are night lamp is 0. It is 10 15 instead of incandescent to CFL or bed light. You go for CFL LED, how much energy we can reduce, how much electricity we can reduce. It's a simple example under energy conservation. So for the development of the to reduce the implement energy conservation measures, Government of India come up with the Energy Conservation Act in the year 29 September 2001. Under that, we have to go for proper accountability, proper auditing quality by proper measuring, detecting and controlling. Again, adapting all these energy conservation management. So energy management we have to adapt under mainly by giving proper awareness among the public. We save more than 40,000 megabytes. Without any single proper awareness training is very much required. In addition, adopting all these parameters. So there is a guideline issued by the Government of India as per Energy Conservation Act objectives, and also they issued guidelines by the Bureau of Energy Efficiency by Government of India. Under that, we have to go for based on the Energy Conservation Act. Each states in our country they have come up with the Energy Conservation Act. Under that act in Karnataka, we have made mandatory of solar water heating system, urban area compulsory, use of CFL, use of ISI marks pumps, and also promotion of energy efficient building, that is energy conservation building codes. So this is the carbon credit, that is called clean development mechanism. Those who are going to generate electricity from the renewable sources, those who want to reduce the losses using energy efficient, they will get some carbon. That is called clean development mechanism. Why global warming? Because of the industrialization mechanism, etc. We are using the petrol, diesel, coal, etc. Because of the emission of carbon, other greenhouse gas, there is effects are there in the global warming. That is melting of the ice cap, rise in temperature, melting of the ice case. There is a variation in temperature, etc. This is all due to increase in. What is the solution? There is a negative effect in the flora, fauna, depletion in ozone layer. There is a melting of the ice caps, rise in temperature, and there is also variation in the health, agricultural, forest, coastal, etc. What is the answer to all those things? So you have to use inside global warming is reduce carbon dioxide, use clean energy, develop forward. Under that, in the 1980, they come up with the action by World Committee. Under that, we have to go for adaptation mitigation by tapping renewable energy and also energy conservation measures. So it also gets some benefit from the developed countries and the developing countries. Under clean development potential areas are there, you will get some initiatives from the developed countries. So we have established National Training Center Solar in the year 2010, and it is now closed. Under that solar, it is a Government of India training center established in Karnataka government and collaboration Government of India. CM is the chairman. So now it is not functioning. It is completely closed. In our training center, we used to give training all India level, all government officers, even now. So now it is closed. Now I will take up the wind solar hybrid system. Hello, hello. Hello. Hello.
Yes, sir. Yes, sir.
Madam, I will continue another 10 minutes, madam.
Okay, sir. Okay, sir. We have time. Including questions, we have time.
Madam, after 1:15, we will close. Again, after start about 2:15, wind energy
sir.
only.
Okay,
Now
sir.
I will
Okay,
take up
sir.
wind solar hybrid system, madam.
Okay, sir. Sir, question answer also
Madam,
should be there.
Madam, audible is okay, madam?
Yes, sir. Yes, sir. In between, the voice was breaking, but it is not a big problem. Can manage.
Okay,
It's
okay, madam.
just-
Okay. Some problem is there. Electric supply problem is there. Anyway, no, I will manage, madam. Okay. I will continue.
Okay. Yeah, thank you, sir.
Okay, thank you. So energy, energy, environment, ecology. For the overall development of require energy, parallel we have to protect the environment, thereby our economy also improves. So in this time we have to protect the renewable
Excuse me,
is very
sir.
much
Slide
required.
is not-
So the energy, environment,
Excuse me, sir.
economic system, wind solar hybrid system. Under wind solar hybrid system,
Excuse me,
suitable
sir.
for individual and 60% and supply. It is the combination of wind solar hybrid system is the best combination among the renewable energy sources. So here, so to develop new generation, why we record renewable energy? Already I mentioned about the solar energy. Now we'll go to the wind energy, small system. Up to 100 kilowatt, you will get a wind solar hybrid system. The effect of the seasonal variation is very important. Whenever the solar is there, that will take care. Whenever wind is there, that will take care. So whenever, for example, night time solar will not be there, other time wind will be there. During rainy season, wind will be there, solar will not be there. So depending on seasonal variation and depending upon the night time or rainy season, you will get the wind. So both will get generation. You can generate DC, AC also it is possible. You can store the battery. You can get the AC, DC also. It is possible. So up to 100 kilowatt, they consider wind solar hybrid system best combination compared to other combination. So whatever the solar generate DC through charger, you can charge the battery, you can cut the DC loads, or you can connect through inverter AC also possible. Through inverter, you can also connect AC. Up to 100 kilowatt, you will get the subsidy. This is the combination of the solar hybrid system. So it is a small system, a small wind generation ideal complement up to small system means so even 50 watt is available, 1 kilowatt, 2 kilowatt, up to 50 kilowatt system also available. But suppose this is a very good system for in the rooftop system. Now rooftop system one is approved by the government of India 400 watt. It is the optimum solution. Why they have opted 400 watt means so here the wind speed required 4 meters per second. Minimum height is required about 20 meters from the ground level. If it is more than 500 watt, you should not install rooftop. If you want to install, you have to check the building of the strength. That is why after 400, without any problem, you can install rooftop. So hybrid system, we have combination of 400 watt with solar panel. We have demonstrated in Karnataka at various places. It is a very good system for rural applications. In a rooftop also, it is a very good system. So combination standalone wind summer, even depending upon the windy season, night time also combination is good. So a major advantage of solar wind solar hybrid system. Solar wind power production used together. The reliability of the system is also increased. So this is one system installed at that time. Now the cost is for 1 kilowatt. You will get 1 kilowatt with battery and everything you will get it. You will get 40% subsidy from the government, 60% for government and community. Many advantages are there. Here also same advantage are compared with the solar wind. So eliminates expensive main cable, fuel automation will be there, high quality, design for easy to operate. There is no operation zero, only maintenance dependent on the stereo solar panel. No, most no pollution, highly reliable, simple installation. There is no moving part, only wind will be there, that will take care of. That is also no. Accordingly, you can design the system. So general design objective is designing the hybrid system is to adequately match the wind system that is nearer to capacity, both minimum cost of energy. In order to accomplish this, hybrid system has been more compatible power equipment, power requirement, wind availability, type, size. Accordingly, you have to design depending upon the area. So many advantages is there already I have mentioned. Many applications are there. Wind solar, very want you can install, no problem. Ideal for cell phone, farmhouses, guest house, hospitals, remote areas, residential colonies, street lighting, transmit communication tower. Many more applications are there. Wherever it is possible, you can install. High output make ideal for virtually any remote battery charging applications. So future it is all microprocessor only. Basic system, air brake automatically that will take care. Even a 360 degree they will rotate. Absolutely, it is all microprocessor control system, all over low cost, low maintenance, no fuel, no pollution, easy installation. A combination photovoltaic and wind is more seasonal fluctuations. So this is system we have installed in Karnataka, 400 watt with 75 watt solar panel, 550 combination we have installed and demonstrated with Karnataka. So very good performance we have achieved. So very good system. Even if installed 400 watt with 150 solar panel, whatever requirement in your domestic, it fulfills all the requirement. So hybrid system for major component, inverters, function, everything is same. So even online also we have monitored online performance of the wind solar hybrid system. That means how much energy we have generated from the solar, how much energy we generate from the wind. So online also we have monitored. So we have get a very good system. So online also we have monitored at various places. Energy output, MNRE guidelines is there. What are the MNRE guidelines? After 100 kilowatt, any combination you can go for. You will get 40% subsidy for individual, 60% for government company. Get be there 2 years, and minimum wind speed required 4 meter. Minimum for 18 meter from ground level. If you want to install more than 5 and more than 500 watts, check the building system. Otherwise, no problem. So these are the system we have installed various places in Karnataka. You can see. So we have installed various places for demonstration as well as in the green concept building, navigation purpose. Various R&D centers also we have installed these systems. So ISKCON, Udupi for navigation, Mandya, Nandi Hills, IGP office, green building, KSRTC, in my native place at Ballari. So these are the systems we have installed at various places. For example, in our native place Ballari, we have installed wind solar hybrid system, 550 watt system. It is a very good system. So this in my native place I have connected in my domestic requirement, as well as I have connected 9 temples in my village. So these are the various temples we have connected. You can see. Basavana temple, Ishwar temple. These systems are we have connected. You can see all those things. So this is one installed in Udupi for navigation purpose. So this is installed in ISKCON temple. This is installed in KSRT Regional Center, Bangalore. This is installed in Government of India Training Center for demonstration. This is installed in the IGP office, Gulbarga, under Green Concept building. So this is installed in my native place, Ballari. So we have also installed wind solar hybrid system, solar water heating system. So navigation in Udupi. These are this is one installed in the Bidar district in Karnataka, Keni Rundal for a street light as well as the temple requirement. So this is wind solar hybrid system we have installed. This is in forest area, remote forest area of guest house we have installed. This is also we have installed at various places in Karnataka. for communication applications. This is installed nearby Chamaranagar district in Karnataka. This is for communication purpose, PNT, BSNL we have installed. Forest area. These are the systems we installed at various places. Even engineering colleges also we have installed. This is Basaveshwara College in Bidar, Bagalkote. These are the places installed at various places. This is installed one ashrama, Vikasana ashrama we have installed. Individual also we have installed. This is in a forest area. This is for commercial only. Akshaya Urja shop they have installed. KPTCL for a demonstration project we have installed in Kaveri Bhavan in Karnataka. In Akshaya Urja shop also we have installed. So one we have case study we have conducted in Karnataka in that is Nandi Hills. So there we have installed 400 watt with 75 watt solar panel. There we have observed 6 months how we have connected all those things. You can see online also we have monitored. Online we have monitored. You can see the things. There is one temple is there, Yoganandeswara temple. There we have connected the temple. Hello? Hello?
Yes, sir. Yeah, till now,
1
it
minute,
was
ma'am.
not there. Now it is clear, sir.
1 minute, madam, because a lot of graphics is there. It will take 1 minute, madam. 1 minute.
Okay,
No,
okay,
no,
sir.
2-3 minutes, madam. I will complete it.
Okay, sir. Thank you, sir. Dear participants, please stay tuned. Sir will be joining us.
Madam, another 3-4 slides for the graphics, no problem, madam. So among the renewable energy, wind, solar, hybrid system, the more optimum combination up to 100 kilowatt, you will get subsidy 40% for individual, 60% community, government and community. So this is a seasonal variation that will take care. The cost also about 1 lakh for 1 kilowatt. But it is more optimal solution for under hybrid system. So this is the brief information about the wind solar hybrid system. Madam, after lunch, I will take up 2:15, madam.
Yes, sir.
So
Okay,
I will
sir.
completely I will take up on wind energy technology. Thank you very much for the opportunity, madam. Thank you, madam.
Thank you, sir.
All the participants,
Thanks, sir.
organizers, principal, staff members, head of the department. Thank you, madam. Thank you.
Sir, so we'll join back at 2:15, sir. Thank
Okay, thank you, madam. Thank you, madam.
Dear participants, so we'll come back for the session at 2:15. So we'll take one hour break now. Thank you. Bye.
Thank you. Thank you.